Hello? Yes, now. Good morning, everybody. My name is Michael Salcher. I'm a managing partner of KPMG. And on behalf of KPMG, I welcome you to Berlin and to our building, which is now 1 year old. We have rented it, so we have not that much money. But we enjoy it because we were located at 7 locations around Berlin, and now we are in this tower, and that's why this tower is called 1, or in German, Eins. I would just like to mention 2 issues I'd like to make you aware of, as it's very difficult, to start such a great event without being too boring. But we have 2, I think our society and our business world, and you can see it in LinkedIn, at this bubble LinkedIn every day, we have 2 issues which engage us very much. One is sustainability and one is digitalization, or AI and stuff. And these 2 dimensions grow together constantly. Part A, AI, digitalization, our conference room names. We had almost 9 months of discussions how to name such conference room names, boarding rooms, because you can name them quite boringly after sightseeing sites or something. So we ask AI to get conference room names for a business building tower in Berlin with a certain reference to Berlin, but without mentioning or without any relation to a Second World War and stuff. So historic incidents which we do not want to mention. So when you look around, and on the other side of the building there's some conference rooms like Berlinale, Himmel über Berlin, Spree, and such kind of things. So this is why KPMG is a AI related company, not only. But yesterday we announced a big partnership, and we are not that much into sponsoring. Maybe some other companies do that quite often. And we explicitly do not sponsor sport events. But we decided to make an exemption. And I just want to show you a picture. Maybe you know these kind of sports, and the man and the team behind that, it's a guy called Boris Herrmann. And we met him for several months, and he's a guy running, sailing across the world, and sailing in a competition called Vendée Globe, an event taking place every 4 years. And we do not sponsor him as a sportsman, but as a sustainability expert and a person who wants to make aware of damages of the oceans, pollution, sustainability issues. And what he's doing is that he transports a computer, because the South Polar Sea is not that much exploited and examined. And he sets out buoyan. I don't know the English word for that. He sets out buoyan, and he has tools above 20-30 kilos with him, and this is a competition disadvantage towards his competitors. But he said we have to have the data. We must we must exploit the data, and we must collect them and exploit them, analyze them, and it gives a great depth into CO2 damages of the oceans, which is a tragic development. And this is why we support him, to make us all aware of what's happening with the environment. So with this short picture and story, I'd like to hand over to my colleague Holger Pott. Again, very warm welcome. Please enjoy the building, please enjoy the day, please enjoy the discussions, and happy to be invited here with you.
Thank you very much. So my voice is not very good today, but I do my best that you understand what I want to mention here. I'm very happy that you're all here today and that we have these expertise in the room and the ability to discuss these interesting topics which are impacting our daily life, which are also impacting what I am doing as CTO for KPMG in my field of consulting. So I'm very interested in joining many conversations today, discussions, and also being part of the network which has been established here. This is basically what I would like to mention here. Most important thing that we are all here together and that you enjoy this event, of course, no? And also use it for your network purposes. Yeah? So thank you very much. Warm welcome from my side.
Okay, warm welcome from my side. My name is Mark Hildebrand. I founded German Deep Tech 22 years ago, I think we should see software as an industrial main strategy project for us, and I hope that today we have interesting discussions, and thank you very much, and I'll hand over to Hans.
Hello everyone, my name is Johannes Bonnet. I'm one of the founders of Seerene. And first of all, I would like to thank you for coming, for being here, for taking the time, and I'm really looking forward to discussions that we will have, the talks, because software is everywhere, and nowadays AI is everywhere, and I think there will be a lot of interesting insights today about these topics and also the impact that it has on businesses and how to cope with all these more and more complexity that comes up with it. So we will have a good day today.
Yeah, I'm Jürgen Dollner. I'm with the Hasso Plattner Institute here on the right side, and I will be quite brief because I will give the first presentation on one aspect that's already here in the slide, disruption. So, Oliver, should I start?
Yeah, please go ahead.
Okay, so it's my pleasure to be here today. Thank you very much for inviting me. This talk is a bit academic. I don't know if I should give you a trigger warning. It's about one topic that scientifically plays a major role at Hasso Plattner Institute. To be more precise, Hasso Plattner Institute for Digital Engineering. We cover many areas in technology, including in innovation management, design thinking, and of course all core topics in computer science. I'm a mathematician, and later I converted into a computer scientist. Now Hasso Plattner Institute has a size of roughly 30 chairs. Within the next 8 to 10 years, we will go to 80 chairs in computer science, mathematics, and other related fields. So it's a rapidly growing institution. So what is the topic of my talk? You might have heard of the phrase, end of programming is near. It's coming. Yeah? And my talk is about why there is no end of programming. Yeah? Okay, so let's start with some general facts. I'm sure you know all these facts. Generative AI turns into a major disruption because it's changing the way humans tend to develop software systems. In the last almost 75 years, humans developed many methods, techniques for humans in order to develop software systems. So we are talking about a human issue. Yeah? And everything was fine. Think of variable names. Yeah, typically you think twice about the right variable name. It's a good name or not. It's a what do my colleagues think in the future if they read this variable name? So it's a typical human behavior that we make programs for other human beings. And this is changing, so possibly everything that was invented in the last 70 years has to be reorganized, and we have to rethink about almost everything. So this change is possibly so significant that many researchers, including myself, think that the current model of software development is coming to an end. And the reason for this disruption is machines start to program machines, and they are different. They have other strengths than human beings. Let's first start with a short review of what is disruption. But before, I just want to show you one of these publications. I found this recently, it's 2 years ago, The End of Programming. And this statement, more or less, is to be discussed. Yeah, I do not fully agree. Matt Welch says, will be obsolete programming? I don't think so. I believe the conventional idea writing a program, this conventional idea of writing a software system is definitely changing. And he argues that AI systems will more or less do the job. But we have to be we have to look at the details, what this means actually. Let's start with disruption. There was a disruption. Many centuries ago, in former times, books have been produced manually. So typically in a monastery, there have been some employees doing a physical copy of the master copy. Yeah, they got a master copy and then they produced instances of this master copy. By the way, they, in that time, these people were aware of outsourcing, so they employed cheaper employees. This is why most historical book copies are full of errors and failures. Yeah, that's something we have to remind also. Then Gutenberg came up with something simple, and people at that time thought, well, they will never do this job because we can paint every letter, every glyph of the alphabet in a such nice way. Gutenberg's press will never do this. Yeah? But as we know, this was a great success. It was, let's say, scaling up the distribution of information, of written information, encoded by natural languages. And it was an incredible boom in business and science. It was maybe the key for the world we know today. But this was not the end of this disruption. Another another big step ahead was PostScript and later PDF. Yeah, we all work every day with PDFs. It's an alphanumeric encoding of the contents of a two-dimensional image representation. If you print out the postscript of one letter, let's say the invitation letter to this event, you would end up in several hundred pages full of stupid commands like you see here. It was developed by Warnock, John Warnock. He lived near a small river, and this small river was called Adobe. That's why the name came up. He founded this company. And this was more or less the end of this disruption. So what we see, Initially, it's always limited, the performance, if you compare it to established solutions. But you can imagine that in the future, it will be much cheaper and much simpler. So scaling and mass adoption comes when the new technologies, the disruption, starts to get mature. In general, it provides a radical change to the existing ecosystem, because there the players share well everything they have to share, and then everything gets different. So new target groups, new markets are there, and in the long term, there might be even much more markets, much more business, as we have seen in the case of printed information. So now I would like to draw your attention to software. How do we develop software? One key insight from a theoretical perspective was a famous paper of Hindle and Barr. Recently I met him, Earl Barr, at Hasso Plattner Institute. And in this first work, he came up with an incredible insight. The insight is programs are not so mysterious. They are just utterances, Äußerungen, utterances of the human being. So programs are artifacts of natural language encoded in programming languages. So this demystifies somehow what software actually is. He analyzed large parts of GitHub, and what he found out is programming languages in theory are complex, flexible, powerful, and so forth. But what we really get, if we look at GitHub, for example, at hundreds of millions of lines of code, then we see that real people actually write, what they actually write is mostly simple and rather repetitive. This is the same in literature. If you look in a bookstore, you will find thousands of books, but if you analyze them statistically, they tend to repeat some core topics. And this can be done by tough and precise statistical measurements. So the statistical regularities seem to be the reason for the predictability of code. This is why code assistants, co-pilots work and can do a great job. And if you ask ChatGPT to write a front end or a mobile phone application, it can do so because because programs can be predicted. It can be predicted what's in there. So this is the reason why generative AI is so successful in software development. It relies on the well-defined semantics and syntax of programming languages. It can also rely on the tons of programming patterns and programming conventions people developed so far. It's a strongly defined language, it's a formal language, but it's a language. It's not so different to a natural language. It's even easier, it's even simpler because it follows strictly a grammar. And we can train large language models on code because we have training data. I mentioned GitHub, but there are many others. This training data is the key why everything can work so perfectly, because we rely on these millions of lines of codes if we predict or if we want to synthetically generate a program. So we can even use complementary information such as discussions in Stack Overflow or the well-known ticket management systems developers tend to produce every day, every hour. All this can be interpreted by LLMs. And for that reason, they are so successful. Yeah? They are used to sequence modeling, and programs fit into this schema. They are linear structures, so to say. Yeah, so the key shift we foresee at Hasso Plattner Institute, and we foresee in theory, is that we have a big shift from doing implementations and while doing so specifying the solution to specifying the problem. And LLMs are quite good in implementing the solution once if it's specified to a sufficient degree. So this is why it can work and why it will work and why it will change the way people create software systems. So generative AI automates large parts of all activities, including testing, requirement analysis, encoding, especially in certain areas. Right now, they are already extremely successful. Right now, 5 years will be different. But right now, for example, all front-end issues and many database implementations can be perfectly generated artificially by corresponding AI systems. But there's one theoretical point I would draw your attention to. The time required for coding will ultimately, and I don't know when this is, will ultimately become insignificant. For new systems. For old systems as well, if you transform legacy code, yeah, you can already see how perfectly they can get transformed and analyzed. Sometimes, if you consider software systems that are already 40 years old, they contain thousands of constraints that have been added and patched into the system. And how to extract these little information pieces is a difficult job, but most likely it can be done to a high degree, to almost to perfection by generative AI. But once, if you have analyzed an existing system, and this is still to be this is still a research topic and will be a research topic for the next 10 years or 20 years even, then the ultimate, the vision is that we can reproduce a similar system that shows the same characteristics as the existing system. Yeah, it's a hard way to go. It's not a walk in the park. Yeah. So the vision that we somehow imagine is that real-time software development on demand. So whenever you need a solution, in this very moment, you generate the software system. You don't have to generate a general-purpose software system in long cycles, in planning for years. What if we can do this whenever we need it? This already happens. Maybe most of or some of you use exploratory data analysis by ChatGPT. You send in or you upload, for example, a tabular data file, CSV, for example, Excel, yeah, and then you ask ChatGPT, what about the distribution of the values? Is there a correlation between A and B? Can you find outliers in in all the records that are encoded in the file? Okay, what really happens if you ask this? Your statement is transformed into a program description. This program description is transformed into a Python script. The Python script uses almost all available statistic packages in Python because it knows the application programming interface much better than all your developers do. And then it executes this generated Python script, extracts the results, and the results are are transformed once again into natural language, and then you get the answer. But when you do the return click, yes, the return button, when you press the return button, a complete software development process is triggered, and it takes at the moment typically 10, 20 seconds. Yeah, it's not real time still, but soon. Yeah. Also, another issue is self-debugging. Yeah, what if the systems start to debug themselves? This is also an ongoing research topic, and it's fantastic because they can. Testing is not the most preferred work of developers. Yeah, it requires a certain mentality. But if machines can do testing to an excessive degree, almost an exhaustive testing, then they get much better, obviously. Yeah? This testing cannot be done by humans. At least you cannot pay for. The prompt engineering, I just sketched it. You write something, the prompt builder internally creates a fantastic prompt. You possibly are never aware of this big prompt behind the scenery. Then it executes a program, and then the code somehow gets executed, evaluated. Yeah? But generative AI is no crystal ball. There's one theoretic aspect I'm very fascinated with. It's within a few years, yeah, what do we really specify? So sometimes a naive fantasy would be that we just give a few statements, generative AI produces an excellent software systems, does exhaustive testing, uses all available programming patterns and so forth. So it would be a wonderful world. Can this be true? Unfortunately, no. Because we have to specify the problem. If we under-specify a problem, the solution space gets too large. If we over-specify the solution, we get a too narrow system or too narrow solution. Yeah? So the specification is key, and from especially from the point of the entropy, in information theory, this is always behind our work with generative AI. We cannot escape from this basic fact that solutions need a certain degree of specification. If you don't tell the details, the system will invent some details, and this is not what we want in real software systems. So, in a sense, programming in the future will be giving a precise specification of the problem, and what specification means, it's still not clear whether this is a kind of narrative text or any other format. The ultimate goal is a just enough specification that leads to a stable and correct and especially deterministic implementation. Yeah? If you generate a software system every hour and every time it's different, it's not what we want, especially in the field of embedded systems. No end of programming, that means we will have to do many different tasks than today, but we will be much faster. Some research topic related to that is how can we manage prompts and how can we engineer prompts? How can we use agents that do all the repetitive tasks and generate, for example, test cases? How can we ensure deterministic code generation, which is key, especially if you think of legacy software systems? How can we specify system architectures that are understood by LLMs, by large language models? And one topic I'm working currently on, how can we design application programming interfaces that are well understood by large language models? So that's, for example, one key in the future that we define or redesign and redefine our systems such that the large language models can understand their functionalities, their parameters, that is, the application programming interface. Otherwise, your libraries get ignored by large language models or get used in a non-optimal way. Yeah, that's all from my side. As I said, I'm with the Hasso Plattner Institute, and feel free to contact me. Thank you very much.
Thank you, Professor Jürgen Döllner. Jürgen will be here for a while. Please ask your questions. But now, let's welcome the next speaker. Oh, someone's working on it. The next speech is dealing with the question, how can you make big business with software development? And all of you are involved in large and huge corporations, and you know that there's a bit of loss, to say the least, along the way. And please, please welcome our next speaker. Please welcome Dr. Johannes Bonnet, CEO of Seerene.
Hello, everyone, again. Yeah, I would like to talk about software development at large. And nowadays, this is like everywhere, on all kinds of mid-sized companies, big companies, they have software development at large internally, no matter what kind of vertical, logistics, software companies, but also all the non-software businesses. And I would like to talk about some very important ingredients to be able to make sure that the software development that takes place is being done in a very efficient way, in a way so that it really supports the business. And before that, I would also talk a little bit about AI in the context of software development. And I start with a well-known sentence, "Software is eating the world," by Mark Andreessen. Back then, 2011, he predicted, or actually he saw, that software will become one of the main assets and the main ingredients in all businesses. Why? Because most of the innovation that takes place in products, in things that are being sold to customers, but also in the way how an organization operates, it's done by software. So the innovation part is usually strongly supported and made by the software. And 2017, there's an add-on to this by Jensen Huang from NVIDIA saying AI is going to eat software, right? This sounds like that AI is eating the software development process. What he meant back then was that it was more focused on how to process unstructured data in the automotive context of self-driving cars, like how to the image recognition algorithms, or how in the health industries, how to make use of all these unstructured data and process this in a reasonable way. This was the focus of what he said then, and he meant that there's not much, or much of the software development as of today, back then, needed to be programmed in algorithm, will be replaced by deep learning algorithms, models, neural networks, like the LLM part, right? It wouldn't be very difficult to program the power of an LLM just by normal algorithms. And now, as Jürgen Döllner also said, right, now the AI has got even much more powerful than imagined back then. It writes code. And the question is here, will AI replace the work of developers? And I want to be here precise where AI sits in the development process already today, and also in future, or at least near future, let's say 5, 10 years, 15 years. And yeah, brief history about software development. Like in the 80s, 90s, everyone who studied computer science, it was about algorithms, bubble sort, quick sort algorithms. You needed to know that, or data structures, how to handle memory stuff. I'm not really sure if this is still a core topic today. If you start studying computer science today, probably not. You're not. Yeah, and why? Because you don't really need it anymore to understand how an algorithm really works, a sorting algorithm, right? Because there are frameworks, because the languages already provide a comfort way of abstracting from that. And sometimes in some domains, specifically in the automotive or in the embedded world, you still have developers who know how to program in C. And they need this knowledge because here it's very optimized. There's not much resources on the chips, on memory, etc. So they need to be very fine-grained in what they do. But normally, if you have a Java backend, you use all the comfort that comes with Java. By the way, Java was so powerful back then because of the framework, not because of the language. Because with simple API calls, with simple modules, just triggering them, you could ramp up a TCP call across the internet, which is a tough thing to do if you would write this in C. So this is when these pre-built fabrication came into play. And then the LLM comes, reads all the internet, reads all the Stack Exchange, reads all the way how developers use these libraries. And that's why you don't even need to know the details about what's in the modules in Java or Python, right? Because the LLM knows much better. You just ask the LLM. And the LLM will pick automatically or will propose the best modules, the best APIs to build the house, right? I'm using the house metaphor here, obviously, which means you're starting to print the house, right? On-demand printing, and not only picking the right prefabricated parts, also the glue in between is being printed. So this looks like actually that software developers are not needed anymore, only some people who know how to speak with the LLM. And this is actually true for some kind of software systems. I would say all software systems that can be built in a software project. Project means start, end. Yeah? And this is kind of big news or fearful news to system integrators. Putting an SAP system in place and customizing or putting the additional ABAP code in it. This is a project actually. And this will be more and more being replaced by the machines. Right? So it will change a lot how system integrators, consulting firms do their revenue, what they offer. If they're smart, they take the developers and give them these tools, and so they're much faster. But over time, this will be total commodity, and this works for all kind of software system where you can define upfront what the software shall do. Right? Waterfall way of programming software, right? You know the specifications upfront, then you do the implementation, or the machines do the implementation. And the majority of software systems, however, they are different. The majority of software systems are systems that are never finished. They are why? First of all, they are not systems where the specification can be done upfront, because it's new land, it's new things, it's specific business processes in a company, not the ones that everyone have. Or it's some specific hardware product where you need to put some specific innovation part via software in it. or its software products itself. And here, it's not possible to do the upfront specification. That's why, by the way, nearly all organizations have switched from waterfall methodology to agile methodology, because it's a journey to find out what the users want. So it's this incremental approach it's necessary for these kind of software systems. And as I said, it's not a project. It doesn't end. Every day the world turns. The old business processes change. The software needs to be adapted, or the users want some new stuff, some other ways what the software shall do. So the software will have to be adapted. And what it means in the house metaphor is that the house that you initially created with that software will evolve into something totally different, right? So this is an art exhibition in Vienna. So imagine you started with that one family house here, right? At the end you have a big office building or library or museum or whatever, right? And you cannot predict this upfront. So software development means and will mean these incrementally reshaping, and it means that you need to take care about many things, about all these, Jürgen Döllner said that in legacy systems, and I would call it normal software systems, like the grown software systems, there are so many, over time, so many sometimes contradicting specifications have been ingreded. And this will be the future still, right? LLMs, generated AI won't replace this, because these kind of software systems will underlie an evolution, and also the architecture. So you need smart people doing these kind of jobs. And if you look at the software development process, by the way, no matter if it's waterfall or agile, it's the same. You have users, they want some behavior of the software system. Then you have people that translate this into requirements. Then you have people that break down the requirements into work items. And then you have many people converting specifications into code, new code, but also adapted code. A lot of code have to be maintained and over the time, and then it goes into CI/CD testing, etc., and it goes up to the end users again, and then the next iteration starts. Right. So this is how software evolves as a cycle, and generative AI tools now. Actually, I want to focus on where most of the money flows into. Most of the money is the salaries of the developers here. There are also many opportunities to use Gen AI across the entire process here, but I want to focus on the developers. And what's happening here, that developers do not have to write every code line by themselves. They become more prompt engineers, and taking specifications, asking the LLMs, the generative AI tools, for their best code they would propose, or the machine would propose, and then they need to be smart enough to say, okay, no, that's not a good idea, or that's a good idea. So developers, and this is also big news or fearful news for developers, they need to upskill. Right? It's not possible to be in a company, to be developer, but stay on this junior level, because this is all the repetitive stuff that you've been done as junior level developers. This will be replaced. It's not necessary anymore. It's necessary to think like a senior developer or like an architect. Like, does it fit into the big picture? What's being proposed here by the tool? And we measured, in many companies, we measured the impact what happens if developers get these tools in their hands, right? Are they faster? How does the code base look like afterwards, before? And what we saw, and this is something, representative charts and KPIs and numbers, what's happening. One thing, we saw that the amount of code being produced per time, per developer, boosts up, a factor of 3 usually. So developers are much, much faster. By the way, I called it here productivity. I better like the word throughput, right? I'm kind of cautious with the word productivity because creating a lot of code it is not necessarily being productive, right? But you see that the speed of creating code gets faster. What you also see is that a little bit after this, the amount of time that's necessary for doing bug fixing, defect fixing, this boosts also up, right? That means it's not enough to give developers these Gen AI-based tools. It's like a tsunami wave that you're creating then, and then it hits into the testing and quality assurance. And if you do not have the test automation there, the so-called productivity is being eaten up by the side effect of the defects that's being created. Another aspect is complexity of the code. Here, what we measure here in the graph down here is one facet of complexity. It's black, white, yes, no, undisputable part of complexity, which is nested code in very nested structures like if, else, if, else, and then comes the code. And this is a kind of complexity you find in COBOL, called PL1, host mainframe languages, but Java, C, C++, Python, modern, and every modern language has these kind of complexity, and this is the #1 ranked facet of complexity, which creates headaches for developers. And what's happened? What if developers take these coding assisting tools? They blow up the code if they don't know what they're doing, right? Because it works like this. You have like if, and then you ask the LLM, please go over the database, get all the names and combine it with this and that, and there are additionally 3 ifs in it. And what we measured here is the amount of lines of code and deeply nested structures divided by developers per week. So this strongly shows you that here developers are in place who do not really know how to handle these tools. They pollute their code, right? And create the future problems. And by this, by the way, a highly complex code means, after all, again, more defect fixing. So it's a vicious cycle here. So having seen this, means it does not necessarily have to be, right? If developers are smart enough, if they're skilled up, if they know the pitfalls of all these things, you can harvest all the productivity issues and getting a grip on the risk aspects here. But for this, it's very important to have transparency about how your organization works. And this is I said it initially, this is the key ingredient from our perspective to be able to do successful software development at large. And it's not only a key ingredient, it's a must-have. And very important, it's important that top-level management feels responsible for that, because it's not enough if you tell the teams, here you have the tools, and you should see if you work out, and if it's complicated for you, then do upskilling, right? That's not enough in a large organization. You need measurement, transparency, and top-level responsibility, so that you're sure that your entire organization gets this higher level of excellence. And this is something, by the way, which, what is nowadays possible, taking the data that is already being collected by the software developers. Data is the code itself. The code changes, by the way, anonymized, otherwise it's difficult in the European space, workers' council issues, ticket management system, etc. There's data there, you can combine it, you can create KPIs, reasonable KPIs that are not technical, by the way, but in a common sense language. And then you see how each of your organizational unit performs. And this kind of transparency creates an inherent drive for everyone in the organization to get better and to improve. It's also a way how to see without effortless to bring a huge change process in your organization just by transparency. Everyone wants to get better because now, you're seen somehow. And on the right-hand side, you see one thing that this is from our perspective, one of the core things to look at is efficiency. It means developers are the scarce resource in the production process, software production process. And you need to make sure that the time of developers can be used for creating business value and not being lost for these kind of inefficiencies, like hitting into complex code, having constantly fight back the defect backlogs, etc. And you can measure this. And you can measure this across the entire organization. And typically, by the way, today, an organization, if we turn on the light with Seerene, new client, the numbers usually look like this, like 70% of the developer time is lost. Why? Because until now it was not possible to quantify this and to see this. And usually I frame this in a positive way, say, okay, nice, you have a good, big potential, a huge potential. And if this were 1,000 developers in the organization, it means a lot of money, a lot of power that is not being used today, right? 1,000 people, roughly 100 million euros per year just for salaries, plus the overhead roles or scrum masters and all the, so it's even bigger. And if you can just convert by this transfer, by this transparency effect, some of these percentage of loss into productive time, it's big money and big power that you can just harvest out of nothing, because it's already sitting in your organization. So it could be cost cutting, but usually it's more about having more power, being faster to innovate, right? Because speed of innovation is also a big thing as of today. Automotive, Chinese speed, all these things, right? The faster you are, the more likely it is that you are not obsolete in 5 years or 10 years with your organization, right? You have to be fast. And this is one of the ways to accomplish this. And what we also see is, because it is a no-brainer, right? Interesting aspect happens when we talk with people in top-level management positions. And here it's about personality. And we see one big impediment, which is fear of transparency. Sometimes, and this is kind of the easiest part, sometimes the fear sits in the person that we speak with, because I did my job for the last 25 years, the way turning on the light might be not the best idea, right? So this is the easiest way, because some years later there will be someone else in this top position. The other fear, which is more a bigger impediment that we see, is that top-level management asks if I turn on the light and if I make it possible that every org unit gets some kind of quantified measurement, what do our people say, right? Sometimes it seems for me that people need to be kind of brave to turn on the light. This was like, let's say, 2 years back in time. Now, as the economic situation out there has become tougher and tougher, right? It's really a no-brainer. Because if you do not use the potential, if you do not have this transparency in your organization, it's kind of negligent as a top leader. So this is what we see today, that that personality matters a lot in doing this, in creating this transparency. But but more and more, it becomes common sense to do it. So from our side, I would like to close this talk by saying, first of all, the software development inside of a big corporate sounds like a technical thing. Actually, it's not. It's a strategic business thing. And if you do not get a grip on this, it's kind of negligent how you work. So it's top-level management responsibility. First of all, to create transparency, to see where you are, where you stand as of now, and putting everyone into the light. And this also creates a gamification effect in the organization, because, right, if you know how fast you can run, right, others will run faster, so you create this intrinsic motivation in the organization. So this is basic thing to do, but it requires some kind of personality also to be kind of brave enough to really do this. And having done this, you can do or combine this with all the improvements and improvement initiatives to make your organization better. And one of them would be to hand over the Gen AI-based tooling to the developers. And there will be more technical things in the next years, advances that there will be, or some organizational parts. For example, if you choose another third-party vendor, it would be interesting to see what's the difference working with the old one, now with a new one. Nowadays, if you don't measure, no way to see if this was a good choice or not. Or organizational models like putting a lot of development effort into so-called best cost countries. Is it a good choice? If you do not measure what's happening with efficiency, with complexity, etc., you don't know, right? So it's really a must-have to have a continuous data-driven governance across all the changes that you do in your organization. And if you do it like this, the chances are very high that you will be the one who wins the race at the end. And I do not mean the race on technical level, I mean on the business level, because this is all to support business. Thank you.
Thank you, Dr. Johannes Bonnet of Seerene. And now, let's see what the automotive industry is doing meanwhile. Please welcome Alexander Springer from... Just a second. Robert Bosch. Yeah, Alexander Springer von Robert Bosch.
Okay, thank you. So, many of the statements which already have been raised, I have packed in my presentation here as well. So, who am I? I'm Alexander Springer. I'm working for Robert Bosch for now 35 years. And I'm a kind of enemy in the Bosch world due to the fact I'm a software guy. So Bosch, I would just like to give you a short overview on what is Bosch. We have about 470,000 more than this associates. Associates in the production, associates in sales, in marketing, in research, and of course in development. And we have roundabout, the number is unclear. We really do not know how many those are. Roundabout 60,000 software engineers, or people called as software engineers. And thereof, we have four major business fields like mobility, industrial technology, consumer goods, energy, and building technology. And I'm one of those people working in the mobility area. The mobility area is round about 61% of Bosch's sales. We have had last year 90 billion euro in sales, and we got an EBIT of 3.1 billion euro from operations. And of course, in the mobility, again, we have round about 61% of this sales. And we are worldwide, we have about 490 subsidiaries in around 60 countries, and we have 150 nationalities working with us. And that's a big asset. And I'm coming to this due to the fact that software business is a people business. We already talked about that the future will be machine-driven, AI-driven, and so on. But in the end, all of the data which is fed into all of those AI data lakes has been created by people, by human beings. And this is what we need to consider all of the time, that we really have to think about the people doing this work. And of course, we are on the first place in patent registration in Germany, and of course, a forerunner in AI-driven things. And of course, I used AI in this presentation several times, and maybe later on there's going to be a little bit fun in it using AI. And we just heard about gamification. And this is what we are doing now, attracting the people by gamification. And with that gamification approach, we can teach on a very easy way how to use Gen AI and all of the tools which remain to that. In all of our products, we have artificial intelligence in it. Our former CEO, Volkmar Denner, he raised the vision that in 2020, he want to have in each and every product AI in it. And this is now already done in directly as in the product AI or within the product production facilities using AI to get there. Now coming to the point where I'm from. I'm the mobility guy. I always worked in the mobility area starting. I had the discussion just from a couple of minutes ago. My first project which I did was a ABS system for Mazda, which I programmed in assembler. Yeah, so I'm the one sitting here in terms of software development. But anyway, this journey shows you the journey of the vehicles. Starting in the 19th century, end of 19th century, with pure mechanical things. In the mid-50s and 50s, we came to electrical things. And by beginning 80s and 70s, we introduced computing power. Okay, first in small little controllers, Bosch Motronic. Yes, you're right. It was 1967 where the Bosch Jetronic, an electronic system, was introduced into the cars for efficiency, for exhaust treatment, and so on and so forth, to be really efficient in your engine management. Of course, yes, later on as well. And yeah, we come from pure mechanical effect chains to electrical systems, to electronics, and now, today, to software. And Bosch is now, meanwhile, 130 years old, and we faced those disruptions all the time. And this is one of the big things which Bosch always had to struggle with. But in the end, we really managed to get through it, coming from mechanics to electronics to software. And now we are on the step coming from software to AI or whatever else is there. And we had the best cost countries just mentioned. We have around about 30,000 associates sitting in India and Vietnam doing coding work. And this AI disruption is the disruption on their daily business. And we have to think about how to use them and what to do and how to get this transformation going on. Let's have a look now into the into the latest past. So we have the shift to electronics. You just said it, Bosch Jetronic. Then first introduction of microcontrollers, having ABS ESP, having basic navigation, but the software role was quite minimal. When I started with Bosch, I was the crazy guy doing software. And I always thought to myself, okay, hey, what the heck are the hardware guys thinking about that they are the master of the world? Because without software, the hardware does almost nothing. Yeah, they are just producing heat, and that's it. And okay, but with software, there comes the functionality into it. And the functionality increases all the time. Looking into the 10s of the 20s, we have the shift to efficiency and to safety technology. Functional safety as the master keyword in this, then hybrid management software. So that means also efficiency and electrification is coming into the car. And there is as well the shift coming from 6-volt systems in the early 50s to 12-volt systems, then to, with the trucks, 24 volts, 48 volts nowadays, and 800 volts for the BEV vehicles. And software is getting more and more into the crucial point to be understood and understood by the companies using the software for user experience or for the defining factor of innovation, which is then the birth of the software-defined vehicles. I remember the time, it was 2009, something like that, 8 or 9, when Tesla showed the first Roadster, full electrical vehicle, only 2,500 whatever vehicles to be sold. And all of the OEMs looked at this car, okay, the clearance, not good, and whatever. So clearance Spaltmaß, it's the yes, but anyway, it was looked at, okay, from a purely mechanical perspective. And they didn't understand that there's a massive disruption just right in front of their eyes. Yes. And today, they're just looking to Tesla. Okay, how does Tesla do it? And this is always the question which my management also always asks me. Okay, how would Elon do it? Okay, not so much now in these days, but last year. Okay, and this is the birth of the software-defined vehicles, having OTA updates in front, having digital cockpits, having personalization, having things to be really done in your car for your personal view, for your personal things which you like. And this is all done with software. And that's the crucial point, software-defined vehicles. But anyway, what's the next point? Software-defined vehicle, okay, has now everyone. What's the next big thing? The next big thing is really having the car as one part of the mobility. We're not talking about software-defined vehicle anymore. We're now talking about software-defined mobility. That the vehicle is just one part in your mobility journey, that the vehicle is kind of a host for your software, for your personal software usage. And this needs to be realized by full vehicle OTA. OTA over-the-air updates, not only for environmental things like firmware updates or so. No, we're talking about features. Features which belong to you. When you have your typically iPhone or whatever, you buy an app, and when you change the phone, the hardware, you still have the app. You just install it on the new hardware, and that's it. And that's the thing, how the cars in the future have to work. A couple of weeks ago, there was the Shanghai Motor Show, and there, the presentation of the cars has been done via influencers. There were so many influencers having here their script on one handy, on the other handy, or mobile phone, they broadcasted live from the motor show, talking about not the cars, about joy to ride, Freude am Fahren, or they are just talking about the features which are in the car, which attract the users. And that's the story which we have to think about. I think all of you might know the Kano model. Kano model means, so you have a dissatisfaction of your product and a satisfaction of the product. There are some basic needs which you have to fulfill. Otherwise, the product will not be bought. Then there are some delighters, the fancy features which attract most. But those fancy features, they switch to commodity over time. When you look at this, you all know this sign here. It's Bluetooth. Bluetooth was invented end of last century. I know in 1999, I had the first contact with the Bluetooth specification, and I said, what the heck? I do not need this. I didn't understand what the potential was in there. But anyway, you see, this is now the basic need. Every single device shall have Bluetooth because you can connect it. And that's the point, what you can see here, connectivity. None of you has a car without connectivity, either it's a historical one. Today, every car has it because it's the basic need. Then maps, okay? Google Maps is always everywhere, but then you need to have an integration of Google Maps into your car. And this is here as well, the environmental things, having all of the surround sensing available, automated parking and whatever else. And now coming into the field on, okay, where are the nice little things which attract you most? Vehicle health is one thing. Having all of those things, especially this, to do vehicle health analysis and giving you hints on, okay, what shall be done, what shall be monitored and whatever else to have your car up and running. And especially for automated cars, when we look into level 4 or level 5, then you need this desperately. If you don't have this, you cannot drive or run as a fleet manager such a car. And on top of this, the delighter is really having whatever kind of functionality which belongs to you as a person is coming with you either in each and every car. For example, you go to Berlin, you get a rental car, you sit in the car, and you have all of your applications with you. You don't have to configure it. This is the seamless mobility vision. It's not yet there, but we are getting there. Chinese OEMs. Okay, the OEMs answer. I think you have looked into my presentation. Could that be? So what is the OEM's answer about this? Yeah, they know, okay, software is a crucial factor in the future of our business. Okay, let's collect all of the software engineers into our own home. So then Volkswagen created Riot, then Mercedes did the MB.OS, Ambition, here in Berlin as well. GM hires 8,000 from new tech jobs in 22. BMW may add 6,000. You see those numbers are quite old, 22, 23. Meanwhile, we have learned a little bit that this hype was not so the right direction, and we have to somehow get back to a narrowed path in doing this. In doing this, this means really to think about what is the innovational part which we have to tackle. What are the features, the ingredients which are really USPs, and not just, okay, I'm doing OTA because I'm the best one doing OTA. Yes. The challenge is that we face many of those things. We already heard it. Digitalization or automatization. Level 3, 4, 5, and level 5, we know this is kind of a vision. 4 might be possible, and we are now working on level 3 to get this into a broader usage.
I strongly disagree.
Yeah?
The future is right here. It's driving in San Francisco in Los Angeles.
Okay, let's talk about this in the break, because yes, you're right, they are driving, but the question is, and this is as well to the point with China speed. I would like to get this discussed. When we talk about China speed is only possible if you lower down your expectations on taking risks, on the functionality, how mature this is. Of course, yes. And but the way how they do it is just as you said, small iteration cycles. Let's get it running in the field and let's try out how does it work. And let's get it improved over time. And we typically are not doing this. We typically are risk averse. And we do not say, okay, let's try it out. No, we have to be 100% or 200% sure that it meets all of the requirements. And this slows us down.
No, the architecture of the vehicles slows us down. What made the industry successful for 40 or 50 years now slows it down in Europe.
Yeah, that's a good point. I took this picture right at the beginning of the legacy. We come from real mechanical things, and we had the electronics starting in the early 80s. And there is an electrical architecture, the E-architecture, which is based on functionalities, on ESP, on drivetrain, on infotainment, and whatever else. Separate things. And the trend is really to centralization. This is what we see here. And when Tesla, for example, starts working, they started with a green field and said, okay, the best architecture will be have one central computer, have zonal architectures, and just do it. With the idea on, okay, let's take an IT paradigm and not the vehicle paradigm. Because all of the functionality can be introduced later on if you have enough computing power. And that was as well a thing which Tesla did right. They had enough headroom available to fill new functionalities into their systems. They are fully equipped with all of the sensors, but it was a downgrade in taking revenue out of it. So they put $2,500 on each and every car which they sold. But that was a pre-invest into future software updates. That was a complete change of the business model. And yeah, where will the road lead us? So it's absolutely clear that the vehicles become smarter, safer, more secure, connected, and more sustainable. Because you need to have range, 500 kilometers, 1,000 kilometers, with one loading of your car. You need to have hundreds of thousands of kilometers for the life duration of the car. And that's as well a difference to the Chinese world. The acceptance or the expectation on a lifetime of a car is 3 to 5 years. Then let's take the next one. Here in Europe or in the Western world, it's typically 10, 15, 20 years. And that's also a very interesting thing. All of the new players in the field, BYD, Tesla, whatever else, they have no legacy. They're just starting. And they started with 1, 2, maybe 3 programs. And maybe they underestimated the complexity in maintaining of all of those things. And as we, as Bosch, are in this business for many decades, since 1980s, we know what it means to maintain all of those different daily built things. And that's one thing where we have a lot of data to really understand what's going on there. And yeah, we need to think not only in our vehicle system, we need to think as well into other ecosystems. For example, you have an e-vehicle, you can use this battery as a kind of buffer for producing energy and giving energy back into the grid. So it's just a possibility, but this is only possible if you think inter-ecosystem. And yeah, I would like now to ask, okay, I said it's a people business. We typically talked about technology, techniques, and what needs to be done. But I'm absolutely convinced that if we don't take the people along with us, then we will fail. Because we will stick to our old habits, and we have to break those habits. And how to do this? Yeah, we need to talk about those behavioral patterns. And that's the reason why I want to invite you to the Monster Land. This is our way on working with behavioral patterns for greater business impact. And again, this is fully AI generated. And you see the world with some nice little colleagues, which I would imagine that you all are quite familiar with. Let me introduce you to the not invented here monster, to the silo monster. Maybe the one or the other could have seen it in the earlier page somewhere. The agility monster, we already heard about it. The spaghetti code monster, as well. Process monster. In big companies, there are processes, and it's the most valuable thing to work on processes. And of course, especially in Germany, the perfection monster. Those are just examples. We have about 16 of them. And so those monsters represent our ingrained behavioral patterns. And we use those monsters to talk about these patterns. We are not talking about the people, or we are not blaming people or whatever. Those behavioral patterns led us to this success we had today. And we have to talk about what does this mean. And what does this mean? Okay, coming back to technology. Just wait. Just wait. We get there. So this is our understanding of our mobility technology stack. Whoa. Okay, having here our verticals, ADAS, motion, energy, body comfort. We had this. Then we have our horizontals with semiconductors, embedded electronics, compute, operating system, onboard, and so forth. We base on the vehicle typically, and we extend it into the off-board world, having services, having cloud backend infrastructures. And this is comprised with processes, methods, and tools over the entire chain. Now I'm talking about, okay, there are disruptions coming on. And you see it already here. We have there some pillars, and there it is, the silo monster. What does this mean? Silo monster is nothing bad. Hey, we got there because we had a great success in motion. We had a great success in energy, body, and comfort. But the interaction between those pillars, I would not say silos, is quite hard. And to talk about this, what is the blocking issue? This monster helps us. Due to the fact we have in each and every meeting room those cards. And whenever we observe in a meeting a monster, we just take this card and say, oh, sorry, I just heard that there could be, and maybe we should talk about it. And, but there's another one. Maybe let's look at this. It's the not invented here monster. They have, no, I can do it much better. And my solution is much, much better than the other solution, and I'm faster and whatever else. Doing this 5 times, you end up in a minimum 5 solutions doing the same thing. So therefore, the not invented here monster shall be addressed if you find those things. Coming to my job, so what I am doing. So I am responsible for the BBM, Bosch Mobility, common frameworks. So what I'm doing is analyzing, defining the product architecture, having reference architectures, guidelines, and architectural pattern, how to implement and how to do our products. Then using processes, methods, and tools to seamlessly work together. Imagine we have about 50 years of tools in our entire portfolio. We have more than 3,500 tools today in operations. And that's far too much. That's far too much. And we said, okay, let's define this for the entire mobility and try to get a tools heat map which shows us the future tool set, to reduce it to a number where we get scaling effects and where we get the same kind of understanding how to use those tools, so the methods. We bring this into a warehouse, all of the architectural building blocks and the solution building blocks, that you can easily reuse them. And the frame is just providing you the infrastructure, the sandboxes, and the shop floor to do your work. And all of this is done with a operating model. And of course, there are as well some monsters in it. Let's look at this. Okay, here's the perfection monster. I know my architects. They have always constraints, and there could be there and whatever else. Yeah, our major thing is, okay, let's start with the 80% solution, and then let's go on to the next things. Here, okay, that's also a nice little monster. We have done it the way as we did it the last millions of years. Okay, because when you're used to a tool, that's a typical login, you won't change it. That's the reason why Excel is so beloved by many, many engineers. And of course, okay, that's right. And this one is the process monster. So, process monster, because those things here are in that. Now, this is the way how we talk about the transformation and how we bring artificial intelligence into our daily life, because this is a platform. So look who's here, .bosch.com, it's an internal platform. You can just click on it and then generate your own behavioral monster. Yeah, and it's about gamification. We offer there a platform just learning how to do prompting. You can generate those pictures just by adding things, editing things into this prompt. And meanwhile, it's just 4 months that we launched this page, and we have more than 80,000 different generated monsters. And there's a Hall of Fame, there is a wall where you can just click and like and whatever. And yeah, this is the way how we go into getting the people, getting technology to the people on a kind of gamification approach, and of course, to make behavioral patterns to be talked about. That no one has a fear that he is blamed or she is blamed about their past, just to have this. So, I would now like to end with a small video of my organization, and maybe you find somewhere the spaghetti code monster. So if someone finds it the first time, the spaghetti code monster, the one can get those cards. Okay.
Let's talk about software and services.
The entire mobility industry is changing, and so are we at Bosch.
We see the multiple challenges and face them head on.
As the only player offering end-to-end solutions, from the bit in the sensor to data analytics in the cloud.
We are convinced that a good sparring partner is essential for the challenges of future mobility.
A partner with whom you can envision the business of tomorrow holistically.
Across the entire tech stack, all domains, and throughout the entire life cycle.
It's about continuously working on pains and gains and understanding the ecosystems.
We need seamless interactions, meaningful interfaces, and maximum interoperability.
Collaboration, cross-departmental, team, company-wide for a common goal.
We stand for partnerships that give you enough room and flexibility for individual solutions.
We develop almost all vehicle subsystems in-house, from automotive electronics and vehicle motion to energy management and cross-domain computing solutions.
We work agile, empower teams, and distribute leadership responsibilities.
Exactly what you need, a team of experts.
Let's master the mobility of the future, together. Let's move like a Bosch.
So, thank you. And here, where was it? It was this sticker. I have a lot of stickers with me. You can grab them and spread them wherever you want. And here it's your package.
Thank you very much, Alexander Springer, Vice President at Bosch. Let's discuss in a small coffee break.
Computer science. This image here computer science.
Okay. Let's get all back at our seats. Okay, let's follow up with the program and please welcome Mr. Henning Heidkötter, Dr. Henning Heidkötter, VP and Head of AI Core at SAP.
Thank you, and welcome from my side as well. Pleasure to be here and talk today about two topics. Artificial intelligence and frequent software delivery. A bit of my background, I'm leading the central AI platform development within SAP, so we are providing the platform on which then other teams at SAP build AI use cases, and yeah, if you're a customer, you may have heard that we've been doing quite a lot of that, building AI use cases into our standard software. But I've always been in the AI space until 1.5 years ago. I was actually, besides other topics, responsible for a rather internal software delivery tool, so similar to what we just saw in the presentation before, a tool that specifically SAP teams used to frequently, daily deliver their software, their cloud software to production. And it's this combination, this intersection of the two topics that I want to take a look at today. So first look at the pace that we see in the AI ecosystem, and then look at what does this pace mean for the common principles, common beliefs that I guess many of us share when dealing about frequent software delivery, ideally daily software delivery. Do those beliefs, do those principles still hold? And how also to apply them to this new dimension, right? So in addition to code, we now have AI in our software systems, how to deal with this as an additional artifact that needs management and that needs to be delivered frequently. One word, just as an caution, when I'm talking about AI, it's specifically about using artificial intelligence in building, not in building software, but in the software itself. So providing use cases that are AI powered, so it's less about or not about using AI for building the software itself, but really about what does it mean, how do I build use cases that are powered by AI that benefit from the advances in AI overall. And these advances are many. Just to look here, at the pace that the space of large language models has seen over the past years. So we always see here the top model, the frontier model of each of the different AI labs. So the green here is OpenAI, not surprisingly, really the first one that kicked off the Gen AI wave end of 2022. And then with GPT 3.5 Turbo, really the first model that propelled a lot of the innovation that we have seen since. And OpenAI has got a good run since then, maybe a bit less in the last years or in the last quarters, but afterwards they led again with GPT-4, GPT-4 Turbo, GPT-4o, so for quite a long time the leader here. But what you also see is over time, of course, other vendors came into the picture. Anthropic with Claude 2, I believe, was the first one here. Google entered the race, Mistral as another provider, and there are, of course, many more that I didn't depict here that entered this race. And what you see is, initially the gap was quite large, right? I mean, intelligence here is a metric of different things. There was always, of course, a use case where maybe Google Gemini with their long context window was the best model for certain use cases, etc. But if you aggregate across different metrics, there was still quite a noticeable gap towards the best model that OpenAI offered at this time. But you see already just a year later, Anthropic closed in quite close to GPT-4 Turbo at that point in time with their Claude 3 models shortly after basically was on par with OpenAI. And that's the pace that we have seen since then. Two things to take away from this picture for the next parts of the presentation. First, there are many more vendors coming up, many more models to consider when you build an AI use case. When it in 2022 was obvious you want to build a generative AI use case, you need to pick GPT 3.5 Turbo. I'm simplifying a bit, but that's more or less it. If you do it today, right, you really need to see, okay, do I need a model with reasoning capabilities, so O3, etc., up there? Or do I need a model that doesn't have reasoning capabilities but is good at text generation, etc., and that may come from a different vendor. So it's getting more complicated, but of course more rewarding as well to really pick a model that helps in building your use case. And the second thing is the pace is just increasing, right? So back in 2023, GPT-4 was still the top model for half a year, more than half a year, right? Then the next iterations of GPT-4 as well were the king, so to speak, for a longer period of time. But we already see the pace quickening here, and really in the last year, in the last quarters, we see that the top model is frequently changing, right? So was at the beginning of the year still 01 by OpenAI. Now we are at 03 or 4, etc. Next ones will be coming for sure quickly. So it becomes important if you build it becomes beneficial if you build an AI use case that you are really able to quickly also switch between models, right? Use a different model that better fits to your use case, that is maybe also more cost efficient. You don't always, as mentioned, need to go to the top here, right? Because I'm depicting intelligence here. You can, of course, also think about depicting cost that is decreasing, but of course, not similarly for each and every model. So sometimes a use case also doesn't need the top model here, and you may be able to gain better efficiencies by switching a model. So switching a model is crucially important, but what we see is our observation, and I count SAP as one of those organizations here, we suffer from limited agility when it comes to models, when it comes to adapting the prompts that we have optimized for one specific model to the next model, right? And really, I count ourselves in here as well. Teams started with like these basic prompt engineering principles in 2023, etc. Did it with a bit of trial and error, had a success, brought out a use case, and then they were stuck basically with this model prompt combination with which they started. For example, because they actually didn't really have benchmark data back then. They just tried a few prompts and used the one that was best for their specific, or that seemed best for their specific use case, where a few prompts worked, and then they iterated on it, etc., etc. And this has a few results: limited speed of innovation, of course, right? You can't keep up with the space, with the space that I've seen, but that I have shown before. You are maybe faced with limited availability, something specific maybe to some SAP customers, but many have requirements that they do not want to send their data to OpenAI, that do not want to send their data to another hyperscaler, etc. So if you're not able to switch to models that maybe are hosted in other places, that limits the available models that you have. If you always need GPT 3.5 Turbo, you're limited to using OpenAI as your provider. And that last point is a bit combined with the point of compliance, right? Specific data you may not be allowed to send to those models that are hosted elsewhere, right? So all in all, tying oneself too closely to a specific model, defining a specific prompt is costly. And what we've seen is that it often takes a full week of intensive work, so really a data science team, to optimize and test a single prompt for a specific model. So you have a model that you've built 2 years ago for GPT 3.5 Turbo. Now you want to bring it to, I don't know, Google Gemini 2.5 Pro as the newest model to be tested. And this takes some time. And this is combined with what we've talked about also today here before, is combined with this principle of prompt engineering, right? This new, somewhat arcane discipline that came into the software engineering world 2 years ago, where everyone was supposed to become a prompt engineer to work specifically with those models. I don't think that's the case anymore. Those models have become more powerful, right? You need to do less specific prompt engineering, but of course you still need to describe what you want to do. So what we claim is that actually this era or this short time span of prompt engineering is actually over, and what's more important today is actually to have the data, really the benchmark available when building an AI use case where you describe, this is what I want to do, these are the examples that I want to see, this is my test data on which I want to test any new prompt, any new model. And if you have that available, it becomes much faster to switch here. You don't need a full week anymore if you have a good set of test data, so examples for specific data input combinations for a specific prompt. This is what you're looking for. You can define metrics, and then you can do what we call benchmark engineering instead of prompt engineering, right? So instead of fine-tuning the prompt to a specific example, you can also let the machines do it, right? So large language models are very good at also optimizing the prompts themselves. We've seen that in the paper earlier that was cited, where an engineer just gives a basic prompt, and then there's a prompt builder that expands that to a full prompt for building a software system. So with this benchmark data available, what you can enter is actually prompt optimization. You can use specific prompt optimization tools to develop different new optimized prompts. And it doesn't have to be a single prompt for a single use case. It can also be different ones, right? If you have a simpler use case, you maybe route to a model that isn't as expensive. For a more complex use case, you route to a different model. So this is the world we are living in, right? And why I believe that AI makes it as important as before, that we are really able to frequently also deliver the software that we are building, right? That it can't be that we spend a full week to optimize, etc., to take advantage, because it's not just about a single prompt, right? If you really have a business process that uses AI at many different places in this process, it becomes tedious to optimize each and every single one of those prompts by hand. So this is important. And now coming to how do I then work with those AI artifacts in a process where I do frequent software delivery. And here, also in traditional software systems, what we claim, and this is what I mentioned was my job until 2 years ago, providing tools to developers that allow them to confidently deliver changes to their software systems daily. Software systems here, I should maybe say, we are specifically talking about cloud software systems, right? So the embedded AI on automotive, etc., may not really have the same, or not really the same principles apply here, but for cloud software, definitely I would claim that 3 principles, 3 beliefs apply to really be able to confidently deliver changes daily. That's developing of a single trunk, a single definition of the code line. I think many will agree with that. It's about a feature-driven development process, right? So where you introduce new features with feature targets, test them, and then bring them into production. Gradually get feedback on this specific feature and optimize it. And then also doing this daily, really, deployment to production. Doesn't mean that you need to release the feature, right? Maybe your customers are not happy if every day they log in, there's a new feature available, but at least deploy this daily to production, because then this enables also, again, that you really have a single code line on which you're building your system. And what I would now like to do is go through these different beliefs that I mentioned here, which I think are important for confidently delivering those changes daily, and tie them also to the AI artifacts that I just mentioned before. So let's start here first with daily delivery. Why it's important that we really move towards daily delivery, and how is it different from other aspects of the past. Just a short recap here, right? So traditional software development, sorry, the colors are a bit off, right? But you have here a 5-month development phase in on-premise times, a 1 month of stabilization testing phase, and then you release a new piece of software, right? That was how it was working, with varying time frames here for a long period of time. And what then, of course, with digital transformation, with the need for faster pace here came was to shorten that, right? So then you have 3 weeks development, 1 week test phase, or maybe if you do it bi-weekly, 11 days of development, 3 days test phase, etc. All good, a good trajectory, but really if you want to go to daily delivery, you have to really think about this differently, right? You can't, like now, on a daily manner have 7 hours a day developing and then 1 day, 1 hour of the day for testing. You really need to make this a continuous process to be able to deliver those changes in a daily manner. And if we now want to apply this principle, which I would assume many agree to the AI artifacts, to AI use cases, what becomes obvious is what I mentioned earlier, right? That you need this benchmark data, that you need to be able to quickly assess, does this new model help me? Does this new prompt work in production? You need this benchmark data available to still be able to also deploy changes here in a daily manner to your prompts. And ideally, you're even able to optimize prompts automatically, right? So that you don't have this 1 week of lead time in there as well. The second belief, also I would assume familiar here, and most would agree to here, is traditionally in a, for example, Git flow model or similar, right? You would have your main code line, then you have feature branches that come along, then you have the current production code line, you have the next production code line, right, which you enable. So a lot of things to keep track of. If you have a hotfix, you need to backport it to all the other code lines, etc., right? Already complicated if you just have the single service here. Much more complicated if you have it in 3 different microservices. One more click, then we have 3 here in 3 different microservices, because you now need to synchronize across those different here, right, to really have releases that still work, unless you are really good at contract-based testing and you can do this independently. At least at SAP, I haven't really seen this succeeding, you still needed this synchronization point to really see that everything is working as you expected. And luckily, what we at SAP have been able to do, and many as well, I guess, is having really been able to move to a single trunk, which enables quicker deployments. You then need to test each of these new feature vectors, new vectors of the versions of your microservices together, but then you can also deploy much more frequently, but you should also deploy much more frequently, otherwise you block one or the other of those microservices here, right? And what here becomes important in an AI, when developing an AI use case, is of course that you also put those AI artifacts under version control, that they become part of your single trunk in this case, right? So a prompt needs to be versioned together with the software. Different principles possible, of course, you can just put it into the code, then it's maybe a bit hidden. Maybe you have other principles, you can put it in a prompt registry from where you version it and then access it. Doesn't matter as long as it's synced together with the code, ideally then also together with the test data as well, that you have it in one big setup. Third belief, the feature-driven development process may be the easiest to also transfer to the AI world. So, and we've seen it before, right? Each single feature still goes through this whole process, right? We don't do waterfall here, but still each single feature, you just don't start here building it. You need to understand the customer requirements first, then plan, design, code, build, etc., etc. And yeah, quite obvious, doing this with AI use case, AI features should of course be a no-brainer, applying the same principle here as well. To do this, release it, you should probably think about not switching to a new prompt, a new model for 100% of the users, but gradually introduce a new model to observe it in production. Even the best benchmark data will not cover all the specific usefulness here. You need to, of course, also gather feedback to see how well are the AI-based suggestions or AI-based process executions accepted by the users. Do they agree to what the AI is suggesting? Do they not agree? If you gather this feedback data here as part of this monitoring in production, you can then iterate. Again, ideally even add this additional feedback data that you get from the users into your benchmark data set, right? So you start with a benchmark data set for your prompts, for your prompt model combinations that you have manually created, but then you can expand on that with more and more feedback that you get from the users. And one extra belief that is important for getting to this is, of course, here the management buy-in as well, and the management buy-in for really moving to this daily delivery of software, but also the buy-in to not lose track of this when now building AI use cases, right? So all of a sudden managing prompts differently, expecting of teams something differently when they build an AI use case, I think is important. We should really treat here the AI also as software engineering artifacts, treat them with software engineering disciplines like any other code artifacts, right? There is sometimes the tendency to basically start from scratch when it is about AI, right? And then later add in the practices that are familiar to each and every one of us, sometimes also just due to feature pressure, etc. Well, I think what's important from management perspective is to really ensure that this, the practices that we have learned over the past also apply when building an AI use case as well. As to just outlining a few success stories here that we have seen at SAP with this process, right, in the pre-Gen AI area, we have tools that are using this daily deployment, daily delivery to production since more than 5 years now, and have really since then on 99% of the working days, except Fridays, deployed a new version to production. And we've, of course, translated that also to the AI use case. So specifically in my area, we have just recently released an AI agent runtime that now many teams at SAP are using to build their AI agents. We released that to internal consumption a bit over two weeks ago. And when I checked yesterday, we had already deployed it to production 9 times since then. So maybe right now it's already 10 times that we have deployed it here, right? So that shows that you can apply those principles, of course, obviously also when building AI platforms and building AI use cases as well. Good. I'm not sure how I'm on time, if there's time for any questions that may be in the audience. We're looking good questions or comments so far.
So let's, first of all, thank you very much, Dr. Henning Heidkötter, VP and Head of AI Core at SAP. You will be available for a while in the
Yeah, I will be around till 2 or something.
Okay, thank you very much.
Thank you.
And now, please all welcome Professor Wolfgang Preh, CEO of AI Squared.
Thank you. Actually, it's a combination of English and German word AI Quadrat. So, but anyway, thank you for the invitation, and thank you. I'm presenting the slide stack we developed together, Hermann Sickerer from Raiffeisen Software in Austria and myself. Well, probably it's a total by chance, by accident. We didn't coordinate. Jürgen Döllner, I'm not sure if he is still here. He says no end of programming. I by chance picked up the same guy, Matt Welch, and I really want to argue why we should think one step further than what we see today. I'm not sure if there is definitely no definite answer to the end of programming, yes or no, but I was really smiling when I saw the title and the first slides of Jürgen Döllner in the morning. Anyway, so let's see. The one thing, I think it was mentioned a couple of times, it just has started, and one aspect which is also important is human beings. we are not really used to exponential thinking. It's usually linear thinking, kind of a linear projection of what we experience, and exponential, kind of future exponential thinking is what at least evolution didn't gift us. It's something we can it's very hard to imagine. I think everybody knows the example of the paper to fold it 50 times. Paper, I think a tenth of a millimeter after 10 or 24, I really don't know the numbers. I think after 10 folds it's a centimeter, a few centimeters. After 20, I think it's a meter. And after 50 folds, you are, I think, 3/4 to the sun. I mean, so it's really radical. And the other thing is, of course, no exponential growth can continue forever. I mean, the universe is just too limited for that, and our planet anyway. But I'm pretty confident to predict that the exponential growth we are de facto experiencing in the very first stages, we've seen it very nicely in the previous slide stack with the models. It's this kind of exponential curve. I'm pretty sure it will continue. And then there's another point, and this is really something which I would say there is definitely a split in the computer science community, in the science engineering community, regarding the predictability and non-predictability of large language models. How should I put it? Why are we should be much more modest in what we have in front of us. Many still think, we just put in some more effort and can better understand what's going on, predict what's happening. I mean, we could very roughly classify systems we build as humans in very simple systems. We have seen, I mean, the mechanical systems in the automotive presentation. 100 years ago, this was considered super high tech. I mean, the engine, the mechanical engine. Then we have complicated systems, and I would say computer science software, as complex as it is, complicated as it is, it's still just used for building really complicated systems. So everybody with a smartphone, I would consider a very complicated system. But it is one that at least theoretically one can understand. So it's a deterministic machine, and it's so highly complicated, I'm not sure if there's a single person on Earth understanding everything about, for example, the latest iPhone, and from the chip design to the software stack. Very hard to imagine, but theoretically you can imagine, and there's definitely a set of people who understand it completely, otherwise it couldn't be built. And then there are complex systems. I mean, we are sitting here, each of us is a complex system. I think we agree. And there are also, I mean, you could even get to another category, a kind of adaptive complex systems. Climate would be one example. Biological systems are definitely adaptive complex systems. And they have one feature or one characteristic we should all be aware. They are utterly unpredictable. So you can do interventions, you have a hypothesis what happens, and you find out. I mean, does it work? Does it not work? Does it have totally different side effects which you didn't expect? But we have to become much, much more modest regarding what we predict, regarding LLMs. And I think also from the scientific point of view, it's very dangerous to kind of describe large language models as statistically parrots, statistische Papageien. They are, maybe we are a statistical parrot. I mean, our way of talking, thinking is maybe the same, maybe not. And the message I want to really deliver here is the unpredictability of the LLMs. And just think back 2 years ago, most features of LLMs, ChatGPT, whatever, have been discovered. So they were not trained for reasoning, logical reasoning. It was, hey, it has logical reasoning, interesting. But it was not something neither expected nor trained for. So we have a kind of artificial species complex system. And the reason why computer scientists, I would call it hubris, is you understand, of course, the basic building block. I mean, the transformer, I mean, if you would have an afternoon, I could explain it to you. It's 2,000 lines of code. It's not, I would say pretty straightforward. And also backpropagation, all the ideas of neural networks, it's not that complicated. It's really straightforward. By the way, I was, just as a small history of myself, I became professor in Constance, full professor computer science when I was pretty young. And I was kind of forced into the AI area because I had 3 research positions and one guy has done neural networks and wanted to do his PhD with me. I was in software components and frameworks, and so I was kind of forced to learn about neural networks. And back at that time, it was totally a fringe thing. I mean, nobody was, of course, interested in. But yeah, at least I learned it. And for me, I was in Zurich, end of the 80s, at the ETH Zurich. The whole computer science department played Go, so I was really I had played a lot of Go, the Chinese, Japanese, Asian board game, and for me the total thing was 2016 AlphaGo. If you know Go, and I think I would have betted and lost everything, because I said never ever will the software beat the top players. And well, it happened then, and then my company totally reoriented towards AI. So we have I wouldn't say 25 years experience. In the meantime, we did other stuff, but just a short kind of flashback. And something that's the danger. Because the basic building blocks and the basic ideas are really straightforward. I really could do a lecture and teach everybody how the transformer works. But combining it in such a number, and it doesn't mean, Jeffrey Hinton, who got the Nobel Prize, says definitely the artificial neurons we are building are simpler than or different than the neurons we have in the brain. But he even argues that the artificial brain, which we build with the LLM, might be more efficient than the real brain. So backpropagation, everything, it works definitely differently. It's definitely a different mechanism, but we just don't know. We crossed the border to the complex systems. And despite understanding the basic building blocks, and that's a totally new game. And this is why we have to have zero confidence in predicting what will happen, what the LLMs are able to do. Think of like what we do today. I speak to you, you listen, maybe. What you get is a transfer of a few bits per second or per milli. I mean, it's nothing. It's just very little information we can exchange in the analog way. And think of LLMs connected, exchanging terabits, terabytes, what they can maybe do or not do. So just think of that. And yeah, that's a kind of different categories could be discussed, not human-like. We will see. And what I would advocate, and it's this old topic. Do we approach things top-down or bottom-up? Kind of Soviet-style control thing, or bottom-up grassroots things. And I argue for the grassroots market-driven approach, which is definitely what I'm 100% convinced the only way to go. And also something that is enabled by AI, which if you think of introducing AI in a large organization, I think is the way to go. But before doing it, we have seen, so some things are really repeating. AI is eating software, software is eating the world. So we have seen it before. It was, I think, Johannes Bonnet on the slides. And that's exactly the one thing. And I have to tell you a very short history here. What we have seen in the morning, and he cannot argue anymore against me or with me, but so I have the advantage now. The article that colleague Döllner has shown in the morning was January 23. So if you know the communications of the ACM, it's very likely it was written half a year before, kind of through the review process, where he argued where he sees probably the profession of programming going. And then in October 23, after the debut of ChatGPT, then kind of beginning of 23. I think not too many have realized it in December, whatever. And then he updated his view, and it's really a YouTube video worth watching, because I think he pretty much got the idea, and this is why I also said before we will go one step further. And now we just watch a few minutes of that video. It's starting somewhere in the middle where he tells the kind of history of computer science. Okay.
Computer science. This image here is also kind of
have to see it.
Going to be seen as a relic of the past at some point.
Maybe we start
this
again.
Idea that
perfect. Genau. Ja, das passt.
Human, they're paid a lot of money, they're writing code. That's the way we get computers to do things for us.
Lauter.
I'm not sure. So here's one plausible idea. Not everyone will agree with this, but maybe over time the field of computer science looks a little bit like the field of EE does with respect to computer science today, right? Computer science evolved out of mathematics and EE. Didn't exist before. Then the new technology came along and gradually computer science emerged out of those two disciplines. EE didn't go away. As I understand it, math didn't go away either. But how do we think about the relationship here, right? EE is super critical. We rely on it all the time. But do you need everyone to understand it? No, it's a more specialized discipline. So if we think about a future in which people that are building software are not writing programs in the conventional way that we do today, and instead having an AI do their bidding, what does that mean? And I think there's actually a really hopeful side to this, which is possibly this greatly expands access to computing to the entirety of human population. Today, if I was working in a bank in a small town in Ethiopia, places that I visited, and I needed to build some kind of automation for something that I'm doing in my work, good luck, right? Good luck finding somebody that could write the code for me, that could understand my problem, that could iterate with me on it, that could maintain it for me, that could evolve it over time. good luck. But with this technology, maybe that person who doesn't have any formal training in computer science, but understands they've got these spreadsheets and they've got these reports and they've got these things that they need to do, could ask an AI to just do it. That's tremendously empowering. I think we should all as a field like aspire to that level of access to the power of computing. It should not remain in the priesthood. So back in 1984, John Gage said, "The network is the computer." This was a famous catchphrase that Sun Microsystems used. I never quite understood what it meant. But this was the idea, the network is the computer. Well, this is my new catchphrase, the model is the computer. Right? And so I'm not saying that there's no challenges here. I have been painting a kind of rosy picture because I think that it's important for us to understand the tidal wave that's coming and to think about what it means for our field. It is not to say that all the problems have been solved, nowhere near it. The biggest dirty secret in the entire field is no one understands how language models work. Not one person on this planet. And I think if I had, Jeff Dean here or some, Jeff Hinton, I think they would completely agree with that statement, right? This idea of chain of thought reasoning, the idea that I got a language model to perform computation by using the magic phrase, let's think step by step. That was discovered empirically. It was not trained in any model. No one knew it was there. It was a latent ability of these models that effectively somebody stumbled across and wrote a paper about it and said, hey, if you say let's think step by step, the model starts to do computation. Whoa, right? That's amazing. It's amazing that we're discovering that these things can perform computation. And then maybe the silver lining is, a lot of people have expressed consternation to me, but like, really? Programming kind of sucks, right? It's kind of a pain. It's frustrating. It's slow. It's mentally tiring. Maybe we can get to a place where we just let the robots do it and then spend our time doing something else. So that's it. And thank you very much.
Yeah, just probably one comment on Matt Welch. He's not just anybody. He did his PhD at the University of California, Berkeley, was Harvard professor of computer science, and then working for many startups, among them he worked for Google. So he is really deeply into the field. It's not just anybody fantasizing what computer science will be. And his main argument is that the von Neumann Rechner, the von Neumann architecture, will be replaced by a natural language computer. And he argues in the direction that a large language model that controls power plants, flies airplanes, whatever, you should also be able to educate to do an internet banking application or some kind of trivial stuff compared to the other stuff. And so this means that this intermediate level of abstraction programming languages will go away. And of course that's not sure, and it's not going to happen next year, so don't worry. But and I am more in the camp that it will happen, and I don't tell you when. I mean, it could be 10 years, 15 years, or really never. And this is really something which splits the computer science community too. I've been in Berkeley for 2.5 years, and former colleagues there, they are pretty convinced that it goes in that way. But it's not sure, definitely not. And we are kind of experiencing now an intermediate stage. And this was also interesting in the morning keynote. There was then one slide which says, super, we don't need the programming anymore. I mean, but we have to check the code. And this is basically also what you said. And so, so we have a speed up, we have the code, we have to check it. That's the status now. But think of the sheet of paper. and going to the sun. I mean, this is a different story. Anyway, what does it mean? I mean, here is just listed, it's even, I mean, computer science is really fascinating which words, the hype words they create. Vibe coding is the new word for natural language programming, kind of. If you have never seen Replit, Cursor, Bolt, Windsurf, Codex 1, the code assistant which was just presented by Google, you should take a look. I mean, Replit, it's really unbelievable. I mean, last semester I still argued we have a software practicum at the university in Salzburg, and usually it's a team of 2 or 3 for one semester. It's a pretty intensive programming task. And one application I gave as specification for Replit, in 1.5 hours I had it perfectly done. I mean, so I'm really kind of trying to figure out what to do next winter semester. But anyway, I mean, that's the example. If you look at the slides, it's a Texas Hold'em poker hand comparison where I can take pictures of the cards and so on. So it's kind of image recognition. I mean, it's not trivial to calculate the probability of winning if you have one hand. You have to do a Monte Carlo simulation. Some of you might know. It's not easy and trivial to program that. Anyway, what are the implications? The one is already now, today, and this is also we could discuss because you mentioned the productivity stuff back in, I'm not sure when you introduced AI, I think it was mid-23 or something. It got so much better now, the code generation, and we definitely have the capability to build software prototypes very fast. I mean, the Replit, Cursor, all that stuff is mind-blowing. It's really mind-blowing, and it's exactly what Matt Welch described with this natural language specification. True, you can over-specify, under-specify. Also with this simple application, I just said, we need this and this feature, and please rearrange this and that. I mean, it works. I mean, the agents generate the code, check, and you have the new user interface and functionality then. So it's definitely already here now, the first thing. And the big problem, I think, is large companies. I mean, Raiffeisen Software, for example, has 800 or 900 employees. I don't know exactly the number of developers, or maybe 600, something in this range. It's very tough to leverage that. It's not the top-down approach. Usually doesn't work. Startups, no revenue, no customers, no brand reputation. It doesn't matter. I mean, you just do something, and if it's a problem, it's a problem. You are not really suffering. And how could you resolve the large company conundrum, if we call it like that? I think it's also a buzzword which is often used to create, and it's definitely true, it works. We know it from this Raiffeisen context. They build sandbox environments for teams and let kind of come up in a grassroots way ideas from the bottom. So you don't do it like from the top down, from the C-suite, what could be automated and which projects do we select and what do we do. It's really just trial and error, and you have more or less clearly written policies. It's not something, a sandbox in the sense that you have to have a computing environment sandboxed, blah, blah, blah. Things like you have NDA-bound alpha testers. Sensitive information is restricted, or you have kind of synthetic data sets generated. You have to show measurable progress in a very tightly defined, usually a few weeks, time frame, and if it doesn't work, just get rid of it. And clear conditions for scaling or terminating the experiment. Is it a sand project in the sandbox, or does it really scale up? And also how to communicate about that. And yeah, it's like venture capital, everything. You have 1,000 experiments, maybe one goes up. And this is, I think, the attitude you have to have if you're top management in a large company. Otherwise, it will be a very slow progress and maybe totally failure, because you have selected 3 projects which you thought are super automating or whatever, customer experience making much better, and they totally fail because it was kind of an artificial top-down control style way. Yeah, celebrate quick, low-cost failures. It's a very Silicon Valley attitude. I mean, this is definitely what I learned in the few years when I lived there. Failure is super. I mean, and the quicker the failure comes, the better, because it doesn't work. And that's, I know, Austria, Germany, Switzerland, the German culture is not really the failure laughing culture here. Anyway, but I think with this right mindset from the top and the right kind of culture you encourage, that's the way how you build, how you really harness AI in a way that is appropriate for your organization. Yeah, get started fast, we finish fast. So you have it on the slides, you can read that. And I want to skip that and just come to the end. That's from Hermann Sikora, not my copyright. The next slide. Oops. So engineering managers think what the skills should be: 50% technical skills, 50% people skills, and the reality is 50% actually 50% politics. Maybe that's in the banking context, I don't know. Thank you.
Thank you very much, Professor Dr. Wolfgang Preh, CEO of AI Quadrat. Sorry.
Right, .com.
We can all check out.
I'm still also professor at the university, so by the way. But probably as a last word, sorry for interrupting you, the speculation of Matt Welch is that computer science might become an educational science. So we move into the social sciences department and educate large language models. And the crazy thing about that is maybe really mastering your language, German language, whatever, to specify exactly, clearly, concisely, is becoming much more important in the end, despite the large language models which generate text.
Thank you very much. So you have a lot in common with Jürgen Döllner, who would have said exactly like you now. Okay, let's have lunch. Let's have a break. Let's meet up here at 1:40. So we have an hour to exchange. Thank you. So everybody, welcome back after the lunch. And yeah, please welcome Dr. Bernd Lohmeier, CTO of Bayer AG.
Good, Oliver, thanks a lot. And thanks a lot for having me here. Happy to talk a little bit about a transformation program. While preparing, I was wondering, is it transformation? Is it a little bit of disruption? We still call it transformation because we feel we still have it in our hand. And this is called dynamic shared ownership. And the special topic is that this spreads over the whole company of Bayer. So it's not just IT. It's also R&D, it's commercials, it's production. So basically it's everywhere. And I'll explain to you how this program is being organized, where we are. And the idea is to really destroy bureaucracy. So we turn the company more or less upside down. And we also want to really ignite innovation much more by bringing people much closer together. And we'll see that in a minute. Now, I start with our mission, not to do advertising with the first two slides, but this is front and center of the whole journey we are going through. Luckily, we have really a powerful mission, health for all, hunger for none. So you see we are in a life science industry. We are in the agro business, producing seeds, for example, with innovative traits. So we want to produce 50% more from what is possible with current seeds, for example. We are in the pharma business, treat the untreatable. For example, is just take oncology. You probably have read and heard in many places what is happening there and how many oncological issues can be treated much better than, for example, 5 years ago. And we are in the consumer health business where we just want to have more than a billion people to just live a healthier life, in particular in developing countries. So these are the three areas we are working in. We have three divisions, as said, crop science, pharmaceuticals, consumer health. We have 93,000 employees. Basically, today it's even less. And I was here last year already, where at this point here I had 100,000. Yeah? So you see already a effect of this program. What is happening within the company, where we basically really move out a lot of middle managers, and you'll see the idea behind it. We have 6 billion investment, around 47 billion of sales, just to give you a little bit of a glimpse. So what is this program, Dynamic Shared Ownership, about, and what are we doing here? So basically, and this is very much driven also really by our board, in particular our CEO, Bill Anderson, who brought it in when he joined about 2 years ago. So we try to reimagine the company. And the first topic was, which might sound obvious, what would happen if we always have the mission front and center in whatever we do, which is a very important component. Just imagine each squad, each team thinks about the mission and how they contribute to health and health for all and hunger for none. So that's a very important piece to start with. As said, it sounds simple, but if you think about IT, how many teams do you have? Do we have? And we have them, yeah, where just technology is front and center and you do something, but people easily get lost with this perspective on what does it mean really regarding the mission and the purpose of the company. Now, second component you see here up here to the left, just imagine that all decisions are made by the team doing the work. You don't have steercos anymore. You do not always talk to your boss or to your department lead to make decisions and to move further with your activities. You just decide on your own. And the target is indeed 95% of the decisions are planned to be brought down to the teams doing the work. And that's why we also then moved out a lot of the business, the middle management. Then all teams are built around the customer, so that really the team, in the way it works, the outcome it defines, the output it defines, really thinks about the customer and what does it mean in my daily work. And very important, and I guess you can relate to that, people tend to work for their boss. Yeah? What does the boss want, and what do I need to do to do a good job and be promoted later on? That's something we just want to break completely. It's the customer, only the customer. Managers become coaches. Yeah, as said, no steercos, not asking for approval. They're just coaching and giving advice, catalyzing, maybe also explaining the vision, but the role is changing completely. Then throughout the whole company, thinking about in 90-day cycles and maybe even breaking this down to sprints. So not only in IT, but everywhere where we are, also in R&D, in commercials and so on. So that was the imagination. And then of course, scale like a multinational company, but work at the speed of a startup, so that we have small teams having end-to-end responsibility and just delivering what they are supposed to deliver, and that they are independent. And we'll see that with an example in a minute. So basically, was the imagination, and you see basically what I just said also reflected here. We focus everywhere on critical outcomes. So what is the outcome I want to produce? And we work much more with strong priorities. So we'll get rid of lower priorities. What is critical, what is important, we focus on. It's a very, very important principle we have. Then, as already mentioned, we fully empower the teams or squads. They decide what to deliver and how they want to deliver. And also this based on a very strong collaboration. We'll also see in a minute that squads can just pull people from other areas in a free resource flow so that they get the capabilities and skills they need to fulfill their work and to really take and live their accountability. How do we create value? Customers and products are front and center, and I already mentioned the fluid flow of resources. How do we get the work done? Faster, agile in the whole company, 90-day cycles, and then always retrospectives in between to learn and improve step by step, partially even in 1 week sprints. And of course, how do we show up? We respect differences. Basically, there is no hierarchy anymore. It's just everyone is on eye level. Nobody is more or less important than other people. And that's underpinned by a new approach of leadership. I already mentioned the coach. The coaching role of managers, catalyzing new developments, so it's completely different than in the hierarchical model we had before. Now, how does it go? And I guess more or less I mentioned it already. If we start something, we have a look at the mission. We define long-term outcomes. The 5 years is more for the general business. In IT, we rather have it 3 years. We define long-term outcomes. We break this down to midterm outcomes, which in IT is more 1 year. And then this goes down to 90-day short-term outcomes, which are then worked upon, reflected, and then improved further. And a key component, it's a little bit small here, I also mentioned, so front and center, basically that's the farmer, that's the patient, and that's the doctor. We have in the companies, we have many teams, squads working for the farmer or for the patient. And it's really, you can imagine it, that you might have in Brazil a production team, even have a production unit and producing seeds, for example, for the local market in Brazil. Might be whatever, 60, sometimes 100 people. And they can pull resources or from other areas, like enabling teams. IT has enabling teams, and they can pull resources from enabling teams if they need a developer to develop new IT features. They pull resources into their teams, are fully responsible, have everything in their hand to produce what is needed for the customer. Now, basically, also if you think along the line of planning cycles, of course, we had budget planning, financial planning, often annual planning cycles, lots of work. Budgeting was a nightmare until now. That's completely changed. Meanwhile, it's 90-day cycles. We define our 90-day outcomes, as just described. Then we execute. We do a retrospective. Do we have the right skills? Do we need to change something skill-wise? Do we achieve our outcomes? If not, what do we need to course correct? And then we change direction. So it's a completely change of the way we work. It's quite tricky. Also, if you imagine if you need more financial resources, to move that to other places, to really decide on priorities is not really easy, and we are also still struggling with that coming from the old world. But that's the way how we think and how we move things forward. Now I give you two examples basically on what changed more on the IT side and how this is being done. And the first example comes from crop science, and it's a data application we have for quite some years for R&D. So in crop science, we develop traits, new characteristics of plants. You can imagine that we have 3 to 4 breeding cycles in a year. And for example, one product we are right now developing is short stature corn. So while corn is quite high and you might face difficult conditions if you have bad weather conditions. If you have a short corn, it much better withstands bad weather, thunderstorms, and so on. And we might even see this kind of short stature corn around the world. In 10 years, we probably don't have the former corn anymore we used to have today. So that's being done with this application. So we have data here to plan for seeds processing, yield, and harvesting, to just breed these new seeds with these traits I've just described. Well, classically, what we have today is that we have all this and this whole operating model based on many different layers. We have the application being managed, in this case, by our own people. So that's done in an IT area working for crop science. Then we might have the data layer, even storage servers being handled by another partner, operations middle by one further partner. So we really, until today, and this is right now changing, we have a couple of strategic providers which are helping. Some are doing the infrastructures, others are working more on the application. So we have multiple layers working together, and you can imagine whenever we want to change something, that's quite a difficult exercise. You have to bring together various partners, you have to bring together various teams. If you even want to do a small change, you have a lot of ticket ping pong and so on. So it's very, very difficult and slow to develop this further. The question is, on how does that look like in future? And the new model looks, as we can see here on the right side. We define a product squad. The product squad has a business owner from R&D. That's the owner of the whole application. We have a product manager also from R&D taking care of this. Key users, developers, more from IT, lead architects, all within this squad, which means they have more or less everything in their hand. So they develop the application within their team, they take care of data, they take care of server storage, virtualization, whatever you might think of. And we try to put as much as possible into the responsibility of this one team, just focusing on this one application and just ensuring that this data-driven application, which is really core for us, is handled and developed as needed, here in this case from R&D. Second example is kind of similar, but goes a little bit more in innovation cycles and how do we develop things further. This is an order entry portal, which we have developed as part of the SAP ECC environment. That's a portal where, for example, a farmer can order seeds from us, which are needed for him for his farming activities. That's also a bit of an old-fashioned activities developed some 13, 14 years ago. And here we also developed or defined a team with people from business, from marketing, again, product managers, developers, lead architects. And they are really working in 1 week's sprints. Also from the business side, everyone is included. They develop an idea. How does should the new portal look like? They just do a fast implementation. They test it. They check it directly with the users. They improve it, and then go in 1 week cycles to really improve the application as fast as possible. If we compare development costs here, and what we right now expect is 1/10 of the cost we had for the application we still have today. So it's really it's a different model, much faster, and also much cheaper, which gives you a glimpse on where we are moving forward. And we, as said, we really integrate also people from business into this thinking. So with that, I'm also more or less through already. So you see that we are kind of changing the organization, the way we think, the way we work. I would say we are really quite successful with that. Just as a rough statement, I just mentioned the number of employees we have, and this change came right now after the year end, 2024. We do not really see a change in the organization, so the outcome of the organization is more or less on the same level. We see a lot of teams which are really, really motivated by being empowered, as I've just described. And we think that this will be a successful model for us. Nevertheless, of course, as you can imagine, with such a big company, it's a journey. We are still on. It will take some more time. We, of course, also do face quite some resistance, but we are fully convinced that this will be a successful journey into the future. Thanks a lot.
Thank you, Dr. Bernd Lohmein. Is there any questions?
I have a question. Thanks. Yeah. Very brave move. I wanted to ask, have you thought about, but I'm sure that you thought about, what happens after the...
Yeah, so maybe then, yeah.
Hi. What happens when the crop suit is fully built and it have to go to a maintenance mode? Who is going to take care of it, and who is the owner of this software?
Yeah, that's a very good question where we have heavy debates. Yeah, of course, when we started, team said, yeah, we will continue to take care of this maintenance mode, but it turns out that will be too expensive. Yeah, you cannot keep this organization then forever once it's stabilized. So you need to reach a certain stability level. And what we are doing is we have a quite strong portfolio analysis, so where we distinguish between applications which are really being developed further, which are really important in particular for our end customer business. We distinguish those from applications which are whatever, not at the end of their life cycle, but really in a stable state. And that's something we move into a completely different operating model, which is where in a first step, some internal employees plus an external partners. We have round about 7,000 employees with larger offshoring companies. The first step, we do it in a joint model, and then in the next step, we then move the complete maintenance and so on to external partners once it's stabilized. So that's our model. Otherwise, we believe it's too expensive to do it forever.
Oh, there's another question.
So thank you for your presentation. It's really interesting. And what I wanted to know is when you say you decided to have the teams full responsible for their solutions, and when I think about some data clients, some data analytics in the cloud, and so on and so forth, then maybe the danger could be that several solutions in different solution fields might occur which do the same thing. Do you experience that as well? Or how do you deal with data which is collected on one side and could be reused on the other side?
Oh, yeah, thanks a lot. That's a very good question. And first of all, we experience what you're describing. That's something we still experience, and we are still on our way. I really honestly need to confess that. There are several thoughts around it. Not sure how is it in your companies. Maybe you can also relate to that. For me, in such a big company, there is a certain tendency towards a little bit of silo thinking. Yeah? It's maybe it's even human. Yeah? And so we still see that happening, depending, as you can imagine. Pharma is also quite different from crop. Yeah? And that's why we see these overlaps. That's definitely the case. Second, we invest a lot of money, since you mentioned data, into data assets. What are our core data assets? Just take patient data. And patient data you have, for example, in research, but you also need patient data, for example, even in commercials. And these are fields where it took us a long time to really move that together, but we are here now getting much better. Meanwhile, you even can exchange patient data, have patient data between consumer health and pharma. So based on this data asset thinking, and that we really have a clear overview on our data assets, we hope that we can reduce the overlap. Whether we can avoid it remains to be seen.
Thank you very much. Thank you, Dr. Bernd Lohmann, CTO of Bayer.
Thanks a lot.
Please welcome our next speakers. It's a double feature. Please welcome Dr. Jürgen Sturm, Senior Vice President of ZF Group, and Stefan Bauer, Platform Domain Manager at Catena-X.
Thank you, Oliver. So, hello everyone and good afternoon. So, Stefan and I, we have the pleasure to, thanks for having us. We have 30 minutes together. And in order to be efficient and effective, so I will start with around 10 minutes and then he will jump in and then he will tell about the real world. So I'm the one looking at things from a management perspective, but he's really doing this. And we wanted to really do something like, in German, a Werkstattbericht. So to see what's going on. And maybe, so Stefan, I will push the button, 10 minutes. Oh, sorry, I now it says 30 minutes, that's wrong. So, and then it will be your turn. Time is running. So, my humble self, when Oliver Field called me some weeks ago and invited me, would you consider to come to Berlin for this conference and give a speech? I said, okay, I don't know. What's the context? He said, Hasso Plattner Institute, Developers Conference, Software Engineering. And I said, oh no, I would rather prefer to come and listen and learn rather than to speak. So he was not too persistent, but he said, give it a thought maybe, please check whether you have time. And in a couple of days, we can talk again. I think that was more or less the proceeding. Then I looked in my calendar and said, I'm in Berlin anyway. So it's a good opportunity. And I'm a notoriously curious person. So I would love to come to this conference. But more than a listener, still I don't know what to talk about. But then 1 or 2 days later, an idea came up to my mind, which was very important to me, where I would like to share one experience with you and an important question. And this question comes along also with a challenge. I would like to challenge you all to give me feedback, not me alone, but us feedback. But think of yourself where you could utilize such kind of things, because Bernd Lohmann made a brilliant speech how things are accomplished in one large company. Now we, Stefan and I, we take it one level higher even, and just talk about doing such kind of things across different enterprises. I call it community development. And now I come, before I go even into the first slide. So my name is Jürgen Sturm. I studied mechanical engineering and computer science in the 80s of last century, long way ago. There I did go to a research institute, and I worked 6 years on my doctorate degree. There I connected data. So my thesis was on connecting process data from production in electronics production, and I applied neural networks for learning systems to deliver Six Sigma quality, because if you are driving a car, you never need an airbag unless you need it. But when you need it, it should be 100% safe. And this is why Six Sigma quality, and we had a brilliant speech this morning from Bosch, quality is so paramount to everything. And cause and effect relationships, and to use neural networks to detect cause and effect relationships in production, and make then closed loop control for zero defect production is important. And I was amazed how these, there's the colleague from Bosch, I was amazed how already in the late 80s, early 90s, with then-in-time technology 30 years ago, such kind of things did amazingly work. And now think about how we've come along now with the technology. Now, then afterwards, I started at Daimler, became a process re-engineering manager, then ended up as a supply chain executive in the semiconductor business, steering global supply chains, and it's a data game again, because it's also zero or 100% delivery accuracy, just in time, just in sequence. I had to deliver to Mercedes-Benz in Sindelfingen airbag and ABS devices that are have to be right in time there. And but cause and effect relationships across the entire supply chain, it's a data game and a challenge. And afterwards, I became, 1999, I became an IT director. And now, for the last 26 years, I was the CIO in 3 companies. And now here comes the challenge that I want to share with you and the learning. I have been now 26 years in the role of CIO in large companies. I'm currently in my own transformation into my next phase. I will retire from ZF, but what was a life-changing experience for me to work in Catena X. ZF is also a pioneer and a founding member of the Catena X Association. And for decades, I was used also as a CIO, that whenever we have a problem to solve, to build a solution, we did build the solution, or with commercial off-the-shelf software, SAP, whatever, we implemented it, and 2-3 years after, we had a solution. What happens next? We need interfaces to the other companies, and the whole thing starts again. Then we have to again build working groups, etc. Now, community development and radical collaboration is the point we want to talk about. And first, those are big words in radical collaboration. But let me just define it a little bit. From Webster dictionary, there are 4 meanings. Radical, coming from the root. Radix, deeply rooted in the ground. Fundamental, extreme, excellent, cool. But, and I won't read it all. Copilot also gave a nice topic or a nice explanation. Radical collaboration, deep, transformative cooperation among diverse groups. Seeks to break down silos, foster genuine partnerships, trust, transparency, and mutual respect, bringing in diverse perspectives, opening trust, shared goals, continuous learning to master complex challenges no one can solve alone. complex challenges no one can solve alone. And it gives even a nice example outlined the 17 United Nations Sustainable Development Goals, SDG, where no single organization can achieve the goals alone. So think about community development, and this is what we did in the automotive industry, starting from a pioneering group in Germany, but now increasingly with regional hubs across the globe, in Japan, China, different hubs in Europe, North America, South America, to address topics no single company in the automotive supply chain can solve alone, like resilient supply chains, trusted sustainability, effective quality, in a multi-tier collaboration along the different partners in the value chain. And this radical collaboration started 5 years ago, 2020, and I had the privilege and honor to be there involved from day one. And so this is just also an example. Look about the different ESG criteria that needs to be fulfilled, product passes, CO2 regulations. If climate change matters, CO2 matters, and we have to have science-based targets. And if we want to know exactly the product carbon footprint of a car that has maybe 0 mileage, and if we want to know during the production chain so far, what is the how many CO2 footprint has been used, and how many circular economy materials are involved there, we must have data chains that make this possible. There were different alternatives. Could we build one single database for the entire automotive industry? Definitely not. Could we have one software partner, Microsoft, SAP, or whoever? Definitely not. And should we just everybody do and mind your own business in your own company? Definitely not. So we needed to have a collaborative approach based on common interests, shared goals, interoperability framework, trust framework, including the computer science topology and everything that needs to be brought in to have really this safe environment. So what we have built in the recent years, a framework for an end-to-end data chain across the different players in the automotive sector, build it on trusted identity, self-sovereignty of data, because the answer is not that we have one cloud where the one cloud solves all questions. We would never ever, we would like to have such kind of a solution, because then we could, even if this was technically possible, we would not like to have it, because this central intermediary, there are certain risks associated with that. Interoperability, self-governed by the industry. So it's not a database, it's a data chain, an open ecosystem for standardized, secure, and simple environment. Now comes the community development. And this was for me also a new experience. That also T-Systems T-Systems. So T-Systems, Volkswagen, Bosch, several partners even here in this room, we came together, and from day one, for me also as a CIO, I was used at open source. We are used at the Linux community. That's great. But these are these nerds that are working on Linux and all these nitty-gritty things, and we are building upon that. We would never ever use this by our own. Of course, we were using Red Hat and all these topics, but this idea to build software right away from the beginning was unheard of for me. And I think about yourself. This is the challenge I want to think about, where you have opportunities to leverage such kind of approaches, because especially in Europe, when we're talking about digital sovereignty, etc., according to challenges that we all have together, that no one can solve alone, we need to think about such kind of approaches. So there are developers kits, and here Stefan will then dig deeper, where for different topics like carbon footprint or for quality cases on the different layers of specification, vision and mission. I put myself a little bit under time pressure, you know, because this will ring. But starting from the vision, the semantic models, the API specifications, and then including training materials, etc., to set up everything as running software code. And after, so the starting phase in first ideas in 2020, and then really starting in 21. In 3 years' time, we have developed a robust set of functionality together, which then is building the ecosystem environment where all partners involved can continue to develop these solutions, self-governed by the industry. There are currently roughly 180 members in the Catena-X Association. So my time is over, time is running out, but I'm good in time, globally represented. And it's also a blueprint for other industries. And so there's a full technical stack available that is the basis for all partners involved. And I will not go into the different solution kits and the network foundation about all the industry core, the Eclipse data space connector, all these topics. This is not the point now. I want to go deeper. But you see that many partners are investing into this ecosystem, and you have also the freedom of choice that we as users of such kind of solutions, there are different players that are offering their solutions in the App Store of Catena-X. You can then have your choice, but those solutions are interoperable. And so this is kind of the topic. And as ZF, I wanted to explain, as ZF, we contributed into 7 use cases. And we are also a contributor into the open source development. This was for me a complete new experience after being 35 years in the business and 26 years walking in the shoes of a CIO. And I wanted to share this experience. And I wanted to ask you, think about it, where everybody in your area of responsibility could think about such kind of approaches. This could be in the public sector, this could be in health sector. Now currently I'm working with Technical University of Munich on 4 use cases. One is real estate business, for instance. Interesting perspectives. And but I did not want to go into the details. Now I hand it over to Stefan, because Tractus-X, that's the open source vehicle inside Catena-X under the Eclipse Foundation. And sorry for taking a little bit of your time, but I was more or less just on time as I planned it. Thank you very much, and please a big applause to Stefan.
And cool, thank you very much. Oh, I never used such a headphone here. So yeah, thank you very much for having me here. I am happy. I'm basically in the same situation as you. We had a workshop here in Berlin. Normally I'm located in Munich, and with the Catena-X Association we had a workshop yesterday and today, and now I'm here. I'm really happy to be here. Normally I would speak in front of the techies. I'm not sure about the situation here, but it looks like a little bit different than the others. But let's have a look on this picture here. This picture was made on the 4th Tractus-X Community Days 2 weeks ago. And whenever I look at these kind of pictures, I'm really starting to smile. Why? Because we have a really great community, and it's really great what we already achieved in the community itself. And let's go a little bit further. So the idea was to tell you something about my life as a project lead here, radical collaboration in practice. I'm a project lead from the. I'm not working for the Eclipse Foundation, but I'm a project lead. So since Tractus-X is an Eclipse project under the umbrella of the Eclipse Foundation, we follow their rules, and there are some rules related to the roles itself. And in this case, I'm a project lead. I will explain it later what it means in detail. Long time ago, I studied computer science. I was a happy developer, and at some point it changed a little bit. But anyway, I really like having GitHub commits and contributions here. So that reminds me a little bit of my technical background, let's say. And what you can see here, I still contribute. And when I say contribute, then it's a contribution to Tractus-X, to the Eclipse project. My normal job description is a platform domain manager at the Catena-X Association. And today it's a little bit bold. I'm speaking as project lead in Eclipse Structures X. When I would look into my contract, which I signed in 2023 in October with the association itself, there are basically two tasks mentioned. The first one is really a platform domain manager. Here it's like a multi-product owner responsible for further developing of our services. So the whole data space, the whole ecosystem is based on different software components, centralized components and decentralized components. And that's basically my main job. It's okay, but it's not the funny job. So for me, at least, the community-driven part is really the more fun part, and this is called the project lead. So in the contract, it says activating the open source community. And the same situation as for you, it's the first time I'm really working in an open source community, and it's really so much fun. And I hope after my speech, you feel it a little bit, you see it, what we did and what we achieved. That would be the goal. Funny thing, sadly, I was not involved in the monster cards and so on, but I just had a look into the monster card, and I see a lot of monsters here. Just a reminder. And yeah, these are some requirements, some wishes we have related to open source community, to developing in the open source community. But I just want to highlight one from control to contribution. So I think the biggest part also for the automotive industry was here really working together, the radical collaboration, because this is not normal. Normally you would develop your own solutions and so on, as you already mentioned. And this is the very first time also from my experience when the automotive industry works really together. Some competitors, some consultants and so on really work together, share their thoughts, their experience and so on. And this is really nice. And this is still an ongoing job. Even if the consortia ended last year, we are live, we are productive, we are sharing data, and the companies are still working together. And that's great. And that's not only the automotive industry. With the foundation of Trackers X, we try to bring it also into other industries. So I'm not sure if you heard about the other initiatives like Health X, Semiconductor X, Factory X, Manufacturing X, and so on. There are a lot of X's where they want to build data spaces, and the goal for Trackers X is to be the foundation here. So what makes it work success? And I hope it's okay if I'm standing here. I have some issues with the height here. Yeah, we have a neutral governance. So we are under the umbrella of the Eclipse Foundation. So they provide some different documentation, some governance. That's good for us. So because we need something like this, it's a neutral environment. Of course, we are transparent and openness. Not only one company is involved, and that's pretty cool. So what you can see here, the companies which are involved in the contribution, no worries if you don't see your company. It might be the case that your developer didn't map the company with the GitHub account. So there's also Siemens involved, Bosch, and other companies. ZF is also involved, and you see the companies here. What we have a shared backlog. So since we are open and transparent, we do everything open and transparent. We have open meetings, we have open planning sessions and so on, and everybody can join. So even if you are interested and you don't have a GitHub account, you could join. You could just join the open meetings and discuss with the people or just listen. That's also fine. The roles in Eclipse Trackers X. So this is my biggest fear right now. So Eclipse is I have always problems with pronouncing this word, meritocracy. Not sure if it's pronounced correctly, but so what does it mean? So this is the easy part, just to explain it. The more you contribute, the more power or the more responsibility you get. So it's not the case in our system here that if you pay money, you get a better position or whatever. So it's always the case you have to contribute. You have to be an active member of the open source community. And if you're an active member of the open source community, then you can get the different roles here. So normally you start as a contributor. So you provide code or you contribute in our open source community meetings and so on. And that's basically enough. Documentation, code contributions, and so on. So, and if you proved your contributions, then you get elected to the next level. So you could get elected by the community itself, by the other committer. So if you want to become a committer, then you have continually contribute to the community, and the committer elect you. And it's basically the same as a project lead. And that's why I'm again, still proud of the whole system, because I was elected as a project lead. But as I already mentioned, I didn't contribute code. For me, it's more than networking stuff. So I'm responsible as a project lead for the release management, for the open plannings, moderation, and so on. I live for the community. That's the second part. What about the time? Yeah, okay, cool. Since a lot of people are always asking how to become a committer, and this is just an extract from the Eclipse handbook, I just want to highlight something, and I already mentioned it. So if you want to be a committer, and maybe I forgot, a committer means you are able to merge pull requests. So normally, if you are just a contributor, you can create pull requests and so on, but the pull request itself has always to be approved by a committer. And a committer, that's why we have this picture here. A committer is a really not interesting, important, important role for us, because the committer is in the end responsible of the code which comes onto the main branch itself. On our side, of course, we follow the Eclipse guidelines and so on. We have on top some Tractus X release guidelines, and also our committers have to follow these release guidelines. And that's important. For every pull request, a committer has to check these guidelines to fulfill the needed quality itself. And that's why the committer is so important. So as I already mentioned, you have to contribute regularly to the project itself. And this is also important. It's not only about code. It's just working in the community. It's contributing to the community. Show commitment, demonstrate long time. I think that's also clear. And build trust. It's also very important. A committer or a person who wants to be a committer should be also active in the community in the different meetings. So it's something like showing faces, building trust, and so on. So if there is a committer, even if the committer or the future committer has a lot of cool contributions, it might be the case that the committer or the future committer is not elected because he or she is not known in the community. So we are talking here about trust. And that's also important. Some numbers, and we are still proud of it, still #1 project. So when we talk about this project, we compare the different Eclipse projects itself. And Eclipse Tractus X here is still #1. The number here is the pure commits, and there's another statistic by contributors. And also here by contributors, we are still #1. That's a cool thing, and that's also a picture we always show because we are just really proud about it. Some technical resources, numbers, and so on. We are talking here about 57 GitHub repositories, which means around about 23 products. So I talked about services, so the decentralized and centralized components which are necessary to bring up to operate the data space. These are the products itself. We have 4 releases per year. And as I already mentioned, we have open refinement, alignment, and open planning. So really open. The community behind, we have around about 200 plus contributor. This is an important number here for us, the 15 out of 43 active committer. Why is it important? So we have 43 committers in a list, in a GitHub teams, but only in this case, only 15 are active. And to be honest, that's a little bit sad if you compare the committer and you know the committers are responsible for maintaining the products, for the quality and so on, and you see the 23 products or the 57 GitHub repositories. It's hard to maintain these repositories with only 15 committers. That's why I'm also happy to be here, just to raise awareness about what is behind the success and so on. And sadly, also, this is a job for the project lead. If we see not active committer, we have to retain. Is it retain? Retire, sorry. We have to retire these committers. Another nice number, so we have a mailing list where you can get information about the development process and so on. Right now there are 311 people subscribed. We have 8 regular open meetings through the different topics. So for example, there's the Eclipse Dataspace Components Connector, so the EDC connector weekly. There's a portal weekly and so on for the different services we are developing. There are different regular meetings, and you can just also join here, ask the developers, the experts some questions, or if you have some ideas or whatever, you just can contribute also here. And since I love the picture, 2 community days per year, so the next community days are in December. Also here I'm involved, I'm there as speaker. I have a own workshop there, and I'm also in the program committee here. So this is also a contribution to the community. So the working model, I think we talked already a little bit about these topics here. Open and transparent collaboration with GitHub. So we are fully planning and developing in GitHub. There is no Jira or no project management tool or whatever. So we are using GitHub for our timelines. You can see here on the right side some issues, some features we are working on. Okay, you cannot see it, but these are the features. We have the open planning and refinement. We are working in GitHub. Everybody is working in GitHub. The documentation is, of course, in GitHub, and the development itself is in GitHub. And as I already mentioned, the note here, if you're just interested and if you just want to have a look what is going on in Tractors X and what are the people developing there, you can just have a look. It's open. So we have here the open meetings, and this is also not normal. So the people are spending their time to visit the meetings, to host the meetings itself. So in this case, we have 8, not 6, 8 regular meetings and a lot of one-time meetings or planning meetings itself. And when we talk about the planning meetings, for example, just to name here some numbers, for an open planning meeting, we are around about 150 to 200 people in the meeting because the people are interested in what's going on, what are the next steps, what will be developed in the next release itself. Yeah, and also here some numbers. We are Eclipse Tractors X. I'm not sure what I should tell you more. I think the pictures are speaking for themselves. It's a great community. I love it, and yeah, happy for your questions.
Wrap it up, I thought it really important. It is important to share this experience. I never experienced this in my professional time, to work in such an open way across different enterprises. And I think for certain challenges we all face together, it would be worth to give it a thought where else we could apply such kind of approaches.
You could also contact me
afterwards. Happy for your feedback also, criticism, comments, whatever. Anxiety.
Are there any questions on the floor? Then I would suggest, I think, Dr. Jürgen Sturm and Stefan Bauer, and we place the discussion in the coffee break. We have 30 minutes, and I want to say to the live stream, we will finish speaking English, and we will switch to German to get all of us included in a discussion after the coffee break. Thank you very much.
Thank you.
Hallo, lassen Sie uns anfangen. Hier sind jetzt alle benötigt. Wir brauchen jetzt Mithilfe der Experten-Community und ich möchte bitten, sich auch nach vorne zu setzen, sonst fühlen wir uns einsam da auf unseren Barhockern. Ein Experte wie Dirk Wollschläger muss mitdiskutieren, das geht nicht anders. Okay. Oh, ich sollte die Glocke haben, die wirkt besser als meine Stimme. Entschuldigen Sie, ich versuche es nochmal. Es ist so. Wow, was ein Tag. Also ich selber, bei mir gehen noch die Zahnräder, ich fand das total toll. Ich selber war begeistert von der Verschiedenartigkeit und doch von dem Level. Mein Mikro ist? Ah doch. Wir haben eine total gute Mischung gehabt und wir haben die Marketinganteile sehr niedrig gehabt in dem Ganzen, was mich total begeistert. Ich habe schon andere Dinge erlebt von Veranstaltungen. Bitte lasst und lassen Sie uns gerne jetzt diskutieren. Wir würden anfangen hier mit einem Panel, das sich aber, so ist es geplant, dann auf uns alle ausweitet und wir wollen versuchen, genau das zu machen, wofür die Veranstaltung hier ist, nämlich diese Experten. Vor mir sitzt ein Riesenbrain, ein Think Tank, diese Experten richtig zusammenzubringen, damit sie vernetzt sind. Ich möchte die Gelegenheit nutzen, um zu sagen, wir helfen auch mit, wir schicken Ihnen die Unterlagen, die Dokumentation zu und sind immer bereit, sie zu vernetzen mit anderen Leuten. Das ist der Ursprungsgrund. Wir wollen den Stiftungszweck letztlich von Hasso Plattner damit auch verfolgen. Ich möchte zunächst mal die Leute ganz kurz vorstellen, die hier vorne sitzen und dann die bitten, jeweils noch kurz sich vorzustellen, damit alle ein Bild haben, wer da eigentlich sitzt. Und ich sage zunächst, Ladies first natürlich.
Reihenfolge nochmal.
Wir haben ja eine Direktorin von Microsoft, das ist Karin Schweizer, die schon Alumna ist in unserem Netzwerk. Vielen Dank, dass du da bist. Wir haben Olaf Kuhmann, Bereichs-CIO bei EnBW, ein Energiedienstleister, wie wir alle wissen. Und dann haben wir jemanden, den hier alle kennen, eine Person, die keine weitere, weil er schon auf der Bühne war. Das ist Dr. Johannes Bonnet, CEO von Seerene. Und ich kann sagen, der sitzt hier, weil er mir geholfen hat. Ein Kollege von der Bahn ist krank geworden und hat sich entschuldigt. Darf ich vielleicht anfangen in derselben Reihenfolge, dass ihr euch kurz vorstellt?
Ja, gerne. Genau, Karin Schweizer. Ich bin bei Microsoft. Muss ich, glaube ich, nicht viel dazu sagen, was Microsoft macht. Ich leite da in Deutschland den ganzen Bereich, wo es um Applikationsmodernisierung, Cloud-native Entwicklung geht, aber auch alle Developer-Themen. Also die ganze Developer-Plattform. Wir arbeiten viel mit Großkunden, auch zu GitHub-Themen. Also GitHub ist noch ein separates Unternehmen, aber im Prinzip arbeiten wir sehr eng zusammen und wir verantworten von Microsoft-Seite, verantworte ich mit meinem Team eben die ganzen GitHub-Themen auch. Sprich, die letzten 2 Jahre ging es wirklich viel um AI im Software Development Lifecycle. Wir haben mit ganz vielen deutschen Konzernen, also von Großkonzernen bis hin zu gehobenem Mittelstand da gearbeitet. Einführung, wo nutzt man es, welche Mehrwerte bringt es, wo wendet man es an, Plattform-Engineering, aber eben auch ich sage immer zu meinen Kollegen, die rein Data und AI machen, hey, wenn AI zum Leben kommen will, muss es in einer Applikation, in einer Lösung, in einem Agenten zum Leben kommen und wir unterstützen Unternehmen da, Gesamtarchitekturen und Lösungen zu bauen. Genau, das vielleicht auf die Schnelle zu mir.
Dann zu mir, ja. Willkommen und danke für die Einladung. Olaf Kuhmann, gern Olaf, gern Perdu. Wie gesagt, ich arbeite bei der NBW. Bin dort, die NBW ist, wer sie kennt, immer noch aufgestellt, nur der letzte große, der tatsächlich alle Wertschöpfungsstufen unter sich hat, von der Erzeugung in allen Elementen der Erzeugung. Wir bauen nuklear gerade zurück, haben viel Erneuerbare, haben noch ein bisschen konventionelle, weil das als Reserve dient. Haben wir auch die ganzen Netze noch, Netz in Baden-Württemberg, Übertragungsnetz, Mittelspannungsnetz und allem, was dazugehört. Wir haben den Handel und das, was wir Vertrieb nennen. Ich habe die Ehre, dass ich die IT für den Vertrieb verantworte. Vertrieb sind bei uns 3 Geschäftsmodelle. Einmal das Geschäftsmodell B2C mit 2 Marken. Wir haben die Marke NBW, die hauptsächlich in Baden-Württemberg tätig ist, und wir haben die Marke Yellow, die bundesweit tätig ist. Wir haben das, muss ich gleich mal fragen, wer fährt elektrisch? Dann hoffe ich auch, dass die NBW als Ladesäulen-Infrastrukturbetreiber bekannt ist und die Mobility Plus App intensiv genutzt wird. Alles zum Thema Elektromobilität wird bei uns im Team auch bereitet und entwickelt und betreut. Und wir haben noch ein drittes Geschäftsmodell, das nennen wir Utility Service. Und Utility Service stellen wir für kleinere Stadtwerke oder Energieversorger Plattformen zur Verfügung, die selber nicht in der Lage sind oder das nicht möchten, Plattformen, die man in der Energie für Strom, Gas, Wärme oder so braucht, benutzen. Ich habe vorhin schon gehört, NBW und Softwareentwicklung wird nicht unbedingt zusammengebracht. Kann sein, die Energiewirtschaft hat in der Vergangenheit ganz viel auf standardisierte Plattformlösungen gesetzt. Wir haben uns in den letzten 10, 12 Jahren auf den Weg gemacht und haben allein bei mir einen Anteil von ungefähr 65% Make. Wir sind nicht bei 100%, bei der Elektromobilität ist ein bisschen mehr, da sind wir bei 80-90% Make, also Individualentwicklung, alles was für die Elektromobilität sozusagen gemacht wird, von der Mobility Plus App über die Ansteuerung der Ladesäulen bis hin zur Abrechnung und so weiter. Das sind im großen Teil eigenentwickelte Lösungen, sehr viel auf Microsoft Azure. Das zu mir.
Dann sage ich auch noch ein paar Worte. Johannes, mein Name. Ja, als Geschäftsführer von Seerene repräsentieren wir jetzt keinen Großkonzern, ne? Aber wir haben viele Großkonzerne und große Mittelständler als Kunden. Und ich habe damals von Anfang an, also als Gründer bin ich von Stunde 0 an mit dabei und habe immer darauf geachtet, dass ich neben Geschäftsführerrolle auch die Rolle habe, dass ich hands-on vorne mit dabei bin. Das heißt, eventuell kann ich auch so ein bisschen denjenigen spielen, der so jetzt in der Diskussion, der so quer von der Seite in verschiedene Großkonzernsituationen hineingeblickt hat und Herausforderungen dort gesehen hat und auch die Trends, wie sich Dinge entwickeln. Genau. Also, und das ist branchenübergreifend. Ne? Das sind Banken, Versicherungen, große Logistikkonzerne, Softwarekonzerne, ist eigentlich alles dabei und interessanterweise doch immer ähnliche, wenn nicht gar gleiche Herausforderungen. Also egal, was das Business drumherum ist, Software hat sich als das Herz und vor allen Dingen das Innovationsherz all dieser Konzerne entwickelt. Und wir haben es ja heute auch gehört von Vortrag von Alexander Springer, Bosch. Ja, also und mein Eingangszitat, Software is eating the world, also das scheint tatsächlich so zu sein. Schlussendlich geht es dann, ENBW, dann wird keine Software verkauft, sondern Dienstleistung, die aber so massiv auf Software aufbaut, dass es eben ja, ein definitives Must-have ist, da das eben auch gut zu machen.
Okay, ja, vielen Dank. Ich möchte mit einer Frage beginnen, die in meinem Kopf alles zusammensetzt, was ich hier eigentlich heute gehört habe. Ich sehe, dass Konzerne damit kämpfen, reaktiver zu werden. Und wir in Deutschland, wir in Europa, wir haben bei Seerene durch HPE einen europäischen Patriotismus, dass wir Sie und euch alle hier zusammenbringen wollen, um wirklich autonom zu werden und selber sich wach zu rütteln. Denn wach zu rütteln gilt es sich jetzt, möchte ich sagen. Und die großen Konzerne, das ist die Basis unseres Wohlstands. Diese tollen Anzüge, die wir hier anhaben oder so, kommen häufig aus der Automotive Industry, wenn man die zurücktracken würde, die Wertschöpfung, die da passiert ist. Wir sind also in unserer ganzen Konstitution abhängig von Konzernen, die groß etwas erwirtschaften und skalieren können. Jetzt frage ich mal meine Experten hier, die Welt wird Software. Werden wir in Zukunft überhaupt noch, werden wir schnell genug sein oder wird das überhaupt noch eine Rolle spielen? Macht ein Konzern noch Sinn, wenn die Wertschöpfung digital ist? Wird es noch Konzerne geben? Ich weiß, eine große Frage. Vielleicht darf ich dich damit belästigen, Karin, mit so einem großen Brett.
Ist tatsächlich eine spannende Frage. Also ich denke, also zuerst mal ja, ich denke schon, auf jeden Fall. Ich glaube aber, Organisationen werden sich ändern. Ich meine, das war schon bei DevOps, Culture Process Tools, die Kultur steht eben am Anfang und auch die Organisation. Und das sehen wir schon, dass Organisationen sich anders aufstellen. Das haben wir ja auch heute in ein paar Vorträgen schon gehört, dass da viel sich anders aufgestellt wird. Wir haben vorher mit Catena X über Plattformen, Communities gesprochen. Also ich denke, da wird viel mehr schon in die Richtung gehen, einfach weil man agiler auch zusammenarbeiten muss. Wir hatten ja auch ein Beispiel davon, auch in der Ladesäuleninfrastruktur. Es gibt ganz andere Partner, da kann man plötzlich mit einem Retailer und so partnern. Und ich denke, dadurch wird es agilere, andere Strukturen geben in Unternehmen und vielleicht auch kleinere Einheiten, die agiler arbeiten können, auch anders empowered natürlich durch Technologie. Aber ich denke, das Konstrukt des Großkonzerns wird es rein wirtschaftlich schon noch geben. Das ist meine Meinung dazu.
Olaf, du hast ja eine Grundlage wenigstens, ne? Das ist ja nicht alles digital, sondern etwas, was physisch benötigt wird. Wie siehst du diese Frage?
Ja, das stimmt. Wir erleben ja gleichzeitig, und das ist das, was bei uns so ein bisschen die Branche beschreibt, wir erleben ja gleichzeitig auch eine Energiewende, die eigentlich keiner merkt. Also zumindest zu Hause, wenn jeder, der nach Hause kommt, möchte das Licht anmachen und das Licht sollte funktionieren und alle gucken in die Nachrichten, wenn in Spanien, Portugal irgendwie mal für einen Tag das Licht ausgeht. Dafür müssen wir massiv investieren und wir investieren in den nächsten Jahren massiv. Aber die Veränderung dabei ist, wir hatten vor 25 Jahren eine dreistellige Anzahl von Großkraftwerken in Deutschland. Die haben die Energieversorgung sichergestellt. Ein paar Atomkraftwerke, Kohle, Gas etc. Wir haben in Zukunft Millionen von Kraftwerken, die da draußen sind. Alle kennen den Hype von Balkonkraftwerken. Wir haben bidirektionales Laden, was in absehbarer Zeit kommt. Wir haben zu Hause die Solaranlagen, die auf den Dächern sind, die zu Zehntausenden gerade installiert und gebaut werden. Wir haben Speicher, die im Keller sind. Und trotzdem, obwohl das passiert, hat man den Anspruch, dass das Licht nicht ausgeht, dass es stabil ist. Und um das im Hintergrund zu machen, gehört natürlich viel Physik dazu, aber auch immer mehr Technologie. Die neuen Trafostationen haben alle Sensorik drin. Die Art und Weise, wie ich zu Hause die Energie zukünftig manage, das soll idealerweise am Anfang haben lauter Techies Spaß, dann irgendwie nachts die Waschmaschine anzumachen oder irgendwie, wenn der Strom billiger ist, das verschwindet. Das muss automatisiert passieren. Und von daher Großkonzerne gibt es hoffentlich noch, weil das sind massive Investments dahinter, die dafür sorgen, dass das System stabil bleibt. Auf der anderen Seite wird Software eine immer größere Bedeutung. Und da bin ich bei Karin, da muss kleine, agile Teams, Speed ist da, das haben wir heute auch in vielen Vorträgen gehört, ganz, ganz entscheidend. Geschwindigkeit, diese Zyklen, die da in der Vergangenheit waren. Ich erinnere nur an ein Jahr Planungszyklen, die sind heute überhaupt nicht mehr tragbar, die funktionieren einfach nicht mehr.
Johannes.
Ja, vielleicht auch noch es gab vor knapp 5 Jahren den Effekt, dass auch in Berlin die ganzen Mittelständler, Großkonzerne hierhin gepilgert sind oder ins Valley, um Innovation zu lernen. Ja, also weil, klar, als Großkonzern muss ich mich auch verändern. Ich muss schauen, was funktioniert heute noch. Und ich glaube auch die Großkonzerne, die es jetzt schon mehrere 100 Jahre gibt, die gibt es auch deswegen eigentlich nur, weil sie sich konstant innen drin heraus immer wieder neu aufgestellt haben. Also auch jetzt wieder nochmal die Referenz auf den Bosch-Vortrag, aber da diese Schlangenlinie, den Autoweg entlang, das heißt ja eigentlich hat sich das Unternehmen da jeweils wieder ein Stückchen neu erfunden. Und ich glaube, da ist kein Großkonzern, kein Unternehmen heutzutage gefeit. Die riesige Herausforderung ist, glaube ich, dass sich diese Notwendigkeit des Erneuerns, dass das viel schneller geworden ist. Marc, du hast immer glaube ich, eine Statistik, die Lebensdauer eines Konzerns, ne? Also früher waren das Durchschnittslebensdauer von Unternehmen waren ein paar Dekaden auf jeden Fall und mehr. Und heutzutage, wenn man eben es nicht schafft, innovativ zu sein und sich neu zu erfinden, dann ist man auch als Großkonzern schnell vom Markt verdrängt. Und ja, wie gesagt, vor 5 Jahren, da haben wir das hier mitbekommen, da kamen immer Delegationen an und wollten Innovation lernen. Und jetzt glaube ich, das klingt ja auch, Olaf, was du sagst, so heraus, dass es mittlerweile klar ist, man muss diese Innovation durch kleine durch so eine Inkubator-Methodik von innen heraus hinbekommen. Ich glaube, heute Vormittag war ja auch ein Vortrag, wo dann sozusagen dieses Experimentieren auch bewusst gesetzt wird und möglich gemacht wird.
Ich verstehe, der Konzern muss das aus sich selber entwickeln und hat ja noch die Kraft auch, das zu tun. Für mich scheint es immer so, als wenn es den Leuten noch etwas zu gut geht manchmal und sie sich noch als Konzernmitarbeiter so auf so einem endlosen Fluss wehen, wo sie doch viel mehr diesen Schlangenlinien folgen müssten. Okay. Ich möchte jetzt vielleicht zur Softwareproduktion gehen und der KI-getriebenen Softwareproduktion. Das kann man nicht mehr trennen, diese beiden Themen. Und vielleicht frage ich mal in die Runde und bitte gebt Zeichen, wenn ihr darauf was sagen wollt. Welche dieser Visionen, die da auf uns zukommen, ist ja immer die Realität und dann das, was gerade in der Presse oder irgendwo auf irgendwelchen Internetforen gesagt wird. Welche konkreten organisatorischen Umbrüche hat KI bereits ausgelöst und welche bleiben reine Vision? Wo ist das irgendwie ein bisschen zu schnell diskutiert worden? Also gibt es Dinge, die ihr seht, die komplett sich jetzt schon verändert haben in der Softwareproduktion, wo jetzt einfach ein Riesenbruch geschehen ist und vielleicht auch Dinge, die noch warten?
Ich kann mal starten, also auch gar nicht, also die Kundensicht auch, aber auch unsere eigene. Microsoft hat ja auch 120.000 Engineers und am Ende bauen wir auch viel von dem, was wir bauen, für uns selber und sind immer so unser Kunde, Customer Zero, wie es so schön heißt. Also ich glaube, viel ist noch Vision. Ich glaube, man ist so ein bisschen vor 2 Jahren, also im Mainstream, ja, KI ist ja schon viel länger unterwegs, aber im Mainstream eingestiegen und ich glaube, da war die große Vision so, jetzt verändert sich alles sofort. Und das merkt man schon auch technologisch, dass es noch auf dem Weg ist, weil so einfach ist es gar nicht mit KI vernünftige, nachhaltige, sichere, responsible Lösungen zu bauen. Also da passiert ja gerade wahnsinnig viel, auch wenn man sowohl gerade unsere Bildkonferenz anguckt, als auch Google Next und so viel passiert ja gerade in Plattformen, im Standards etablieren. Das passiert gerade erst noch. Aber wenn man dann auch wieder sieht, was in den letzten 2 Jahren passiert ist, gerade in der Softwareentwicklung, hat sich schon brutal viel verändert. Also wenn ich jetzt bei uns selber sehe, fing an, eben bei uns, klar ist das Tool natürlich GitHub Copilot, fing an mit hey, bisschen Coding Assistant, ja, und Automatisierung von repetitiven Tasks. Und jetzt sind wir im Prinzip an einem Punkt, wo man sagt, man hat den eigenen Coding Agent, der eigentlich, wo es wirklich hingeht, den ganzen Software Development Lifecycle von links nach rechts abzudecken, von Ideation hin zu, wir haben jetzt einen Site Reliability Engineering Agent, der wirklich Incidents dann selber entdecken kann, selber nachts um 2 quasi dann aufsteht und nicht mehr die wirkliche Person und auch Sachen fixt. Also da passiert schon wahnsinnig viel und das hat sich schon verändert, was wir sehen, weil du organisatorisch auch gefragt hast. Wir kriegen ja auch viel die Frage, ja, eben gibt es den Softwareentwickler noch, gibt es den klassischen Entwickler noch? Die Rolle verändert sich auf jeden Fall, hat man ja aber auch schon länger gesehen mit Citizen-Developern und ich glaube, das wird verstärkt. Andererseits, ja, wir sehen auf jeden Fall noch, dass es die Entwicklerrolle gibt, aber in anderer Kapazität und was wir bei uns sehen, ist, dass viele Entwickler rücken entweder stärker Richtung Plattform-Engineering, sprich bauen Plattformen, die andere enablen, oder näher zum Produkt und bringen eben genau das inhaltliche Wissen rein und die rein repetitiven Aufgaben in Coding fallen weg. Also da verändert sich die Rolle oder sehen wir bei uns zumindest in diese 2 Richtungen.
Ich würde sagen, wir sind da gegenüber der Microsoft eher der Follower. Wir sind nicht ganz so früh dabei, aber sehen das ähnlich. Die Softwareentwickler, die Software-Engineers, die nutzen natürlich sowas wie GitHub Copilot und so weiter für speziell Coding-Assistenten, repetitive Tätigkeiten. Das ändert aber überhaupt noch nicht die Art und Weise, wie wir Software entwickeln. Ich glaube aber dadurch, dass wir uns jetzt 2 Jahre mit dem Thema beschäftigen, sehen die Software-Engineer als zuerst das Potenzial, was da dran hängt und was das für ein disruptiver Ansatz sein wird. Wir führen gerade die Diskussion zum Beispiel, und deshalb war das auf dem Bild durchaus interessant, da den ersten Agenten für Site Reliability. Ein Softwareentwicklungsprozess ist ja nicht eigentlich nur der Coding-Anteil. Ja, der Coding-Anteil ist wichtig und in die Produktion zu deployen und das irgendwie stündlich, minütlich zu können, das ist eine Fähigkeit, die muss man haben. Aber auch mit dem Demand umzugehen, mit den Anforderungen umzugehen, diese entsprechend in so einer hohen Qualität aufzubereiten, da verändert sich ja auch was. Das ist ja Teil des Prozesses und hinten beim Betrieb, wir haben über Site Reliability gesprochen, ändert sich auch was. Und jemand, der sich mit zum Beispiel Softwareentwicklung beschäftigt, sieht, dass das gerade viel, viel größer wird und dass das tagtägliche Leben und die Arbeit, wie wir heute arbeiten, verändern wird. Von daher, konkrete Frage, hat es schon zu disruptiven organisatorischen Änderungen geführt? Nein, überhaupt nicht. Aber die Ersten sehen, dass das kommen wird.
Ich glaube, in den, also die kleineren Systeme, also zum Beispiel, wenn von Fachseite aus eigentlich IT-Support gebraucht werden würde, um bestimmte Makros zu schreiben in Excel, diese Art, also Citizen Developer, ne, als Stichwort, das ist was jetzt mittlerweile eigentlich jeder Mensch machen kann. Und traut sich vielleicht noch nicht jeder, aber diese Art von IT-Entlastung an der Stelle und auch Zugang zu dem Nutzen von IT und solche Algorithmen. Man muss das ja alles nicht mehr können, man muss es eigentlich nur gut beschreiben können und dann auch ein bisschen Geduld haben, dass man 3-mal, 4-mal iteriert, den Prompt iteriert und dann kann man das als ein kompletter Laie, als eine Laien kann man dann sich Software machen. Und ich glaube, alles, was diese so schnelllebige Fragestellungen sind und kleine Systeme sind, das wird komplett wegautomatisiert sein. Und die großen Themen, die werden trotzdem bleiben, also die Basissysteme und wie du sagst, ich glaube auch, und da wird KI bei den Anforderungen viel unterstützen, weil Anforderungen Sprache und Large Language Modelle, das gefundene Fressen ist da Sprache und vor allen Dingen unstrukturierte, wenn man sich jetzt Anforderungsdokumente anschaut, ist alles unstrukturiert. Da will eigentlich kein Mensch durch, also das ganz viel und dann hinten raus im Operations bei Site Reliability will eigentlich auch keiner um 2 Uhr nachts durch den Pager rausgeklingelt werden und da ist ein Riesenpotenzial.
Ich denke übrigens vielleicht noch ein Punkt, was ich echt spannend finde, ist so auch die Management-Perspektive, weil wir hatten die Diskussion gestern, wir haben inzwischen gibt es eben auch den Coding Agent, das ist wie ein Teammitglied, wie mein Site Reliability Engineer Agent, der Coding Agent, dem kann ich wirklich Issues assignen. Ja. GitHub hat das getestet, viele haben sie halt alte Issues, die immer weit weg im Backlog waren, die keiner gekümmert hat, haben sie dem assignen und der läuft dann wirklich automatisch hoch. Aber vielleicht die Management-Perspektive fand ich spannend, meinte nämlich jemand, das ist ja wie ein neuer Mitarbeiter. Mache ich mit dem eigentlich auch ein Mitarbeitergespräch? Mache ich Feedback-Gespräche? Ja, das ist ja eine Frage, gebe ich dem Feedback und sage, das funktioniert nicht. Also ich glaube, auch die Perspektive ist durchaus mal interessant einzunehmen.
Ja. Also wir haben ihm zumindest einen Namen gegeben.
Ja, stimmt, machen viele.
Ich darf mal kurz zu Sven gehen, der hat eine Frage.
Danke. Also ganz kurz, ich bin von Mayborn Wolf, bin Partner und auch Bereichsleiter. Und auf die Frage, hat sich schon was in der Organisation verändert, würde ich sagen, ja, hat es, nämlich genau die Mitarbeitenden, meine Developer zu enablen, GenAI einzusetzen, egal ob es jetzt GitHub Copilot ist, ein Wissen darüber, wie setze ich das rechtlich sicher ein. Das hat sich zumindest bei uns definitiv verändert. Und ich finde, das ist auch aus Management-Sicht eine ganz, ganz wichtige Perspektive, das aus dem Management den Mitarbeitenden, den Developern, den Requirements Engineers mit auf den Weg zu geben, dass man genau das möchte, dass das die Zukunft sein wird und dass ich dafür eine sichere Umgebung schaffe für meine Leute, dass es genau eingesetzt wird. Weil sonst ist meine Erfahrung, arbeiten die Leute mal mehr, mal weniger damit und meistens mit Problemen in der Code Quality oder anderen Dingen. Also ich finde, das ist schon was sich zumindest bei uns verändert hat und was ich immer stärker merke. Es ist jetzt keine organisatorische Veränderung, dass neue Teams entstehen, aber ich würde jetzt auch mal ganz dreist unterstellen, dass Microsoft da natürlich auch einiges tut, dass eure Developer, eure Engineers mit Gen AI, mit Copilot arbeiten können?
Ja, das Enablement ist generell ein Riesenthema. Also nicht nur mit Gen AI im Software Development, sondern ganz ehrlich, auch wir und im 365 Copilot ist unser eigenes Tool, auch wir haben viel internes Enablement und Activation gemacht, damit die Leute es nutzen, weil man muss seinen Arbeitsablauf einmal umstellen und das muss man halt erstmal tun.
Es gab hier noch eine.
Robert Zillikens von T-Systems. Ich würde gerne die Aufmerksamkeit darauf richten, dass Globalisierung einen Weltmarkt für Dienstleistungen und Produkte geschaffen hat. Und ein Ergebnis der Globalisierung ist, dass auf der einen Seite etablierte Hersteller von cyberphysischen Systemen existieren, die auf der anderen Seite von New Market Entrants beispielsweise aus China oder aus Indien herausgefordert werden. Und die Anforderungen, die sich an diese beiden Kategorien von Unternehmen stellen, vor dem Hintergrund von Machine Learning und AI, sind durchaus unterschiedlich. Wenn wir also über die europäischen Großkonzerne sprechen, beispielsweise in der Automobilindustrie, dann stellen wir fest, dass sie im Vergleich mit chinesischen Herausforderern große Schwierigkeiten haben, mit der Entwicklungsgeschwindigkeit Schritt zu halten. Insbesondere, wenn es eben um so komplexe Integrationen von Supply Chains wie dem Produktentstehungsprozess in der Automobilindustrie geht. Da existieren Codebasen von 150 Millionen Lines of Code, die idealerweise refaktorisiert werden müssen, weil aufgrund technischer Schulden die Wartbarkeit sehr schlecht ist. Also auch bereits leichte Erweiterungen der Scopes zu großen Schwierigkeiten führen. Also es würde mich interessieren, was eure Erfahrungen beim Enablement von Großkonzernen sind, die eben nicht einfach nur auf der Ebene von Team-Experiments mit 20% des Einsatzes der Arbeitsstunden von Softwareentwicklerinnen und Softwareentwicklern arbeiten können, sondern die im Großen ihre branchenspezifischen Supply Chains refaktorisieren müssen. Habt ihr Erfahrungen damit? Was sind eure Vorschläge?
Wow, was eine Frage, ganz schön groß. Hat jemand dazu einen Beitrag? Oh, da hinten sehe ich eine mutige Wortmeldung, wenn ihr erlaubt. Ich gebe.
Robert Fey von Synopsys, hallo. Ich rede relativ häufig über genau dieses Thema online bei LinkedIn und was halt immer wieder auffällt, ist gerade was du gesagt hast, wir tun es jetzt einfach mal, das Entwicklungsmodell ist halt ein V-Modell oder eigentlich ein Wasserfallmodell. Das endet mit einem SOP. Wenn ich jetzt die Software, die über 1 Million Leute entwickelt wird, versuche einzusammeln, zu refactoren, dann ist das halt ein Zusammenarbeitsthema und kein Strategiethema mehr. Man muss sich dem einfach mal bewusst sein, was das bedeutet. Und wenn wir jetzt OEMs haben, die sagen, wir wollen gerne Produktlebenszyklus entwickeln, dann muss ich halt meinen ganzen Laden umkrempeln. Das ist übrigens auch ein Aufruf an alle Consulting-Berater. Verstehen, umsetzen und bitte das Thema treiben. Produktlebenszyklus ist nicht Wasserfall und nicht V-Modell. Das muss man einfach jetzt mal in das Management reinprügeln, ne, wenn das nicht verstanden wird. Das ist nicht mehr Hardware, das hat kein Lebenszyklusende bei der SOP, sondern da geht's los. Und dann fängt Softwareentwicklung an, Spaß zu machen und dann geht Softwareentwicklung los, dass wir das auch verstehen und dass wir es weiterentwickeln können.
Vielen Dank für dieses Statement. Hier noch eine Wortmeldung.
Ja, also ich bin auch mal mutig und versuche mal zu antworten in Sachen China Speed. Wir sind 2014 nach China gegangen, um ein Fahrzeug zu entwickeln, und zwar modellbasiert von Anfang an, und haben die gesamten Daten der Elektronik, EE-System mit 2 Leuten gemanagt. 2017 sind wir zurückgekommen und haben beim Tag des Systems Engineering der GFSE in Paderborn darüber berichtet. Und das einzige Ergebnis war aus Deutschland, dass uns unser Mitbewerber aus Stuttgart eine 7-stellige Summe geboten hat, wenn wir einfach aufhören. Und da stehen wir jetzt beim China Speed. Wir haben in China rund um die Uhr gearbeitet. 8 Stunden in China, 8 Stunden unserer Mannschaft in Deutschland und 8 in den USA. Es waren nicht die Chinesen, die in Nachtschichten da gearbeitet hätten. Es waren wir. Deren China Speed besteht da drin, dass sie sehr schnell entscheiden, ja, mal kurz gesagt, einfach machen. Und die machen es in Excel. Wir haben deren Excel-Tabellen übernommen und haben alles transformiert in ein Modell und haben aus diesem Modell heraus alle Daten generiert für die Supplier. Ja, wir haben die Buskommunikation komplett modellbasiert gemacht. Wir haben das OEMs gezeigt, indem wir deren Bussysteme komplett in Modell gewandelt haben. Und die haben gesagt, ja, irgendwann werden wir das auch mal machen. Ja. So, wenn ich längst in Kuba am Strand liege oder so. Also nochmal, ich habe es schon mal beim letzten Jahr danach aufgerufen. Wir in Europa, in Deutschland, wir müssen uns zusammentun und das umsetzen, was wir in China und auch in Deutschland längst gemacht haben. Ja. Danke Johannes für den Hinweis für den Vortrag mit der Softwareerzeugung. Wir haben 98 haben wir die gesamte Softwareentwicklung für die Fahrzeugsteuerung von Straßenbahnen, Nahverkehrsfahrzeugen auf modellbasiert umgestellt, haben die gesamte Fahrzeugsteuerung seitdem automatisch erzeugt, die Softwareentwicklung von 6 Monaten auf 6 Wochen verkürzt, die gesamte Buskommunikation wegrationalisiert, die wird automatisch gemacht und damit 50% vom Marktanteil in Europa gewonnen. Wenn man heute hier irgendwo in die Straßenbahn einsteigt, ist die Wahrscheinlichkeit, dass sie mit unserer Software entwickelt wurde, ungefähr 50%. So, die großen Konzerne setzen auf ihre Lieferanten, die dann solche Systeme wie unseres umsetzen sollen und das auch tun, allerdings mit 20 Jahren Verzögerung und mit einem Effekt, dass es eben Expertensysteme für Experten sind, aber nicht für jedermann. Da stehen wir jetzt und da müssen wir uns den Chinesen nähern, die sagen, wir sind offen für sowas, wir lassen euch das machen und wenn es nicht klappt, seid ihr morgen raus. Ne? Und die Basis ist, einfach machen. Man muss diese komplexe Welt der Elektronik einfach machen, verstehbar machen, dass es jeder versteht. Und wenn man das nicht tut, wird eine AI keine Chance haben, irgendwas Sinnvolles beizutragen, weil sie auf eine komplexe Welt stößt, die selbst für eine AI nicht mehr zu managen ist und die dem Menschen dann die Lösung, die sie gefunden hat, nicht mehr begreiflich machen kann. Das ist der Punkt.
Vielen Dank für dieses Statement. Und die Begreifbarmachung, da denke ich an den Johannes jetzt, komplexe Systeme einfach zu machen oder überhaupt beherrschbar zu machen. Es scheint mir hier ein Konflikt zwischen der menschlichen Auffassungsgabe und der unendlichen Möglichkeit des Computers zu bestehen. Und du bist jemand, der sich darum hier kümmert, die Sachen verständlich zu machen. Möchtest du vielleicht?
Ja, also gut, das ist eine ganz, ganz alte Kulturtechnik, wie man abstrakte Dinge schlussendlich in ein Gehirn eines anderen Menschen kommuniziert, Bilder, ja, Höhlenmalereien, damit fing das an. Und je komplexer, also ganze Wissenschaftssparte, Information Visualization, lohnt sich übrigens, da mal reinzutauchen. Da gibt es irre Darstellungen von Napoleons Zügen in einem, also quasi irre viele Informationen in ein Bild hineingebracht. Und ja, und wir nutzen das bei Seerene natürlich auch aus. Ne? Also jetzt Software darzustellen, Software ist hoch abstrakt, das kann man ausdrucken, das bringt aber auch nicht viel. Es wäre dann so ein Papierstapel, der hier jetzt irgendwann am Fenster hoch wächst und da sprechen wir nur von einem Kernbankensystem oder das, was im Auto, ne, am Radar sitzt. Und da gute Visualisierungstechniken zu finden, sodass es verständlich wird, sodass auch, und jetzt kommt's, auch Menschen, die von dieser Technik eigentlich keine Ahnung haben könnten, und das sind jetzt gerade, wenn man Automotive herausgreift, also viele Führungskräfte im Automotive-Bereich verstehen Software nicht, können Software nicht verstehen, weil die kommen aus der Maschinenbauerwelt, da wo man Dinge anfasst, und da ist es natürlich umso wichtiger, dass man es schafft, durch Analogien und auch Visualisierung dieses Thema Software, was wie ein Fremdkörper ist, teilweise wollen die da auch nicht rein, weil sie auch nicht sozusagen, die wissen, als Top-Level-Management weiß man wird zerlegt von den Technikern und weil man noch nicht mal die Fragen stellen kann, und da ist es umso wichtiger, durch eine Möglichkeit von Visualisierung es zu schaffen, dass diese Welt der Softwareentwicklung begreifbar wird und damit managementbar und damit eben auch dieses, was ich vorhin gesagt hatte mit der Innovation, dass aus sich heraus ein gestandenes Automotive-Unternehmen sich auch als ein Softwareunternehmen verstehen kann.
Ja.
Vielleicht ergänzend zu dem, was Johannes gesagt hat, das würde ich unterstützen. Ich glaube, in einer digitalen Welt gibt es eine Währung, die funktioniert, und die heißt Trust. Also das heißt, Menschen, die Verantwortung haben, Top-Manager, müssen den Leuten, die dann Architektur machen oder Softwareentwicklung machen, vertrauen. Und Trust erzeugt man auf der Gegenseite entweder durch Visualisierung oder verständliche KPIs. Jeder Manager versteht sowas wie Testabdeckung. Jeder Manager versteht sowas wie bestimmte KPIs, wie ist der Komplexitätsgrad in meiner Software und so weiter. Und deshalb, ich fand das Bild, ich glaube, das war heute früh von Bosch sehr gut, dass es irgendwie so eine Hierarchie von Visualisierungen und Ergebnissen gibt. Also auf der Top-Management-Ebene, wie schnell liefere ich was, wie schnell bin ich in der Lage, Produkte an den Markt zu bringen, wie schnell kann ich meine Lösungen ändern. Auf der Entwicklerebene sind ganz andere KPIs notwendig und so weiter. Aber ich glaube, das hilft, um dann die Akzeptanz für diese komplexe Materie auch auf dem Top-Management zu erreichen.
Mhm.
Bitte.
An der Stelle würde ich gerne eine Ergänzung anbringen. Natürlich lassen sich Metriken wie beispielsweise die DORA-Metriken mit Number of Deployments, Lead Time, Main Time to Recovery und Rework gut visualisieren. Idealerweise als Tortendiagramme. Das versteht jeder Manager. Das Problem ist aber, dass diese Darstellung, und das ist vielleicht auch ein Aspekt, der im Zusammenhang mit Entwicklungen wie Seerene diskutiert werden muss, diese Darstellungen betreffen nur einen Teil des Digital Lifecycle Managements. Und wenn sich das DLCM dann noch einordnet in komplexe Produktentwicklungszyklen, wie in der Fahrzeugindustrie oder auch in der Verteidigungs- oder in der Luftverkehrsindustrie, dann wird das Problem noch viel größer. Und eine Methode möchte ich in dem Zusammenhang anführen. Sie stammt aus der Luftverkehrswirtschaft und ist im Übrigen von Leslie Lampert entwickelt worden, einem Microsoft Fellow. Das ist Temporal Logic of Actions. Das ist eine Modellierung in mathematischer Form, mit der sehr komplexe Systeme sehr stark vereinfacht werden können. Aber auch hier gilt natürlich, das Management muss die Sicht auf den kompletten Prozess richten können. Und eigentlich ist das ein Teil des Problems. Mit Visualisierungen von Teilabschnitten schafft man möglicherweise auch ein Problem einer Scheinanschaulichkeit. Man muss den gesamten Prozess betrachten, und das macht eigentlich nur das Systems Engineering. Und die Softwareentwicklung selbst ist dann nur ein Teil aus diesem komplexen Prozess.
Vielen Dank für diesen Beitrag. Ich würde da gerne mal dann anschließen und was über Messbarkeit und Steuerung überhaupt von Softwareproduktion sagen. Also ich habe heute hier gelernt, oder bei mir gab es ein Riesenausführungszeichen, ich fasse das sehr laienhaft und naiv zusammen, dass man überhaupt wissen muss, was passieren soll. Der Mensch muss noch einen konkreten Plan haben, den er verfolgt, weil die Maschinerie eines Konzerns irre schnell sehr, sehr viele Dinge macht und alle sehr fleißig sind. Und das wird bei uns bleiben. Ich frage mal hier in die Expertenrunde, welche Dinge zur Steuerung und Messung sind für euch die wichtigsten in der Softwareentwicklung? Jetzt versuche ich ein Szenario hier aufzuspannen. Ihr seid CIO von dem super-duper Riesenunternehmen und ihr habt keine Zeit. Wir wissen das. Ich habe gerade dieses Wort reinprügeln gehört in diese Führungskräfte, und die haben einfach immer den Speicher komplett voll. Welches Dashboard zu Steuerung und Messbarkeit würdet ihr favorisieren oder so einer Person vielleicht? Bei dir weiß ich schon, Johannes, eins zumindest der Instrumente. Aber ich frage mal in die Runde, was sind die wichtigsten Dinge zur Steuerung und Messbarkeit?
Also aus meiner Sicht, wenn man das erfolgreich machen möchte, hat diese Medaille zwei Seiten. Die eine Seite ist tatsächlich ähnliche Größen, wie wir eben im Beitrag gehört haben. Also wie erfolgreich sind wir denn? Also welchen Value liefern wir in einer gewissen Zeit, ob das jetzt ein Tertial ist oder ein Quartal, welchen Kundennutzen bringt das denn, welchen Revenue bringt das denn, etc. und so weiter. Dazu gehören dann eben darunter auch sicherlich technologische Kennzahlen. Das ist für mich aber nur die eine Seite der Medaille. Die zweite Seite der Medaille, die wir uns angucken, und deshalb fand ich den Case von Bayer so interessant, die ändern ja gerade gefühlt radikal ihre Kultur von einer zwölf hierarchischen Welt in eine völlig neue Welt. Für mich ist der zweite Teil die Kultur. Ein Entwickler muss sich in seiner Umgebung wohlfühlen. Die Leute müssen eine offene Kultur haben. Die müssen Entscheidungen treffen, die auf ihrer Ebene getroffen werden können, weil das reduziert Wartezeiten, das reduziert Synchronisation und diese ganzen Sachen. Und das ist nicht eine Frage, die ich anordnen kann, sondern das ist eine Frage von einer Kultur, die sich über die Zeit entwickelt. Und von daher, wenn ich mir Sachen anschauen würde, dann würde ich auf der einen Seite diese recht harten Fakten anschauen, auf der anderen Seite aber auch weiche Faktoren, die man gegebenenfalls mit Coaches erheben kann. Zum Beispiel Team Health Check. Wie gut, wie wohl fühlt sich denn gerade ein Team? Sind die zufrieden mit dem, was sie arbeiten? Haben die Druck? Spüren die was? Und solche Sachen. Also diese Kombination aus diesen beiden Elementen würden mir helfen zu bewerten, ob das geliefert werden kann.
Vielleicht ergänzend, also ich finde, es gibt kein Schwarzwald. Also ich finde, es gibt nicht die eine Antwort. Ich meine, hier wurden ja gerade schon ein paar Frameworks genannt, Dora etc. Am Ende kommt es immer darauf an, was bei dir auch implizit Mischung, was will ich denn erreichen? Also wir werden ja auch dauernd von, wenn wir jetzt mit GitHub Copilot, dann haben wir jetzt gerade die Diskussion viele, ja okay, das Entwicklereffizienz, okay, aber ich will ja niemand entlassen, was mache ich denn damit? Ich dann sage, naja, darum geht es im Endeffekt nicht. Die Frage ist ja, was will ich denn erreichen? Und ich glaube, auch bei diesen großen Modernisierungsprojekten, die genannt wurden, ja, die sind nicht einfach, da brauchen wir uns alle nichts vormachen. Wir kommen halt mit den Automobilkonzernen nicht wie eine Tesla jetzt von der grünen Wiese und bauen alles from scratch und können Software aus einem Stück. Da sind wir nicht. Aber auch da, ich glaube, wenn sich damals Top-Management klar ist, wo will ich überhaupt hin, dann kann ich den Weg dahin bauen. Wenn ich aber auch gar nicht so genau weiß, was ist eigentlich mein Problem und bin ich offen, das Problem vielleicht zuzugeben und zu sagen, wo ich hin will, dann wird es halt schwierig, den Weg hin und die Metriken hinzufinden. Also das ist vielleicht der eine Aspekt. Und dann sind es ganz unterschiedliche Sachen. Beim einen mag es wirklich Entwicklerzufriedenheit sein, beim anderen ist es vielleicht effizient, beim einen ist es Code Security, wie viel Incidents habe ich, whatever. Aber ich finde, das ist nicht schwarz-weiß. Was wir zum Beispiel machen, gerade weil bei uns auch die Entwickler-Experience ein großes Thema ist, bei uns heißt Engineering Thrive, ist eine Metrik, die wir uns immer angucken. Und das ist tatsächlich eine Mischung aus genau dem. Wir haben Zufriedenheitsumfragen, die macht jeder Mitarbeiter übrigens bei Microsoft, die haben wir zweimal im Jahr so eine NSAT-Umfrage zu verschiedenen KPIs. Und wir haben aber auch Time to First Pull Request und solche Dinge, die wir messen. Also das ist so eine Mischung. Aber kommt natürlich aus unserer Kultur und dem, was wir mit unseren Entwicklungsteams erreichen wollen.
Also das ist eine richtig schwierige Frage, weil ihr könnt jetzt per Google versuchen, genau diese Frage zu stellen, bekäme auch keine eindeutige Antwort. Es hängt tatsächlich davon ab, was will man erreichen. Was wir, und es haben sich irre viele Köpfe, schlaue Köpfe daran versucht, Messbarkeit, es fing damals an mit den Code zu vermessen. Ja, und dann hieß es, je mehr Code produziert, desto besser. Ne? Also das ist jetzt so 70er, 80er, dann irgendwie Gewichtsfaktoren, wenn es jetzt C++ ist das anders als Java, dann wird das irgendwie so mit Gewichten behangen und das hat alles nicht gut funktioniert. Was wir jetzt die letzten Jahre, ich denke sogar ganz erfolgreich geschafft haben, ist zumindest ein KPI ins Zentrum zu stellen, und zwar mit dem Ausgangspunkt, dass wir uns angeschaut haben, was ist denn eigentlich in den 80ern in der Hardwareproduktion passiert, mit Lean Manufacturing, mit Toyota Management System. Was hat man da gemacht? Man hat geschaut, okay, man produziert Dinge, was für Ressourcen bringt man rein, Energie, Material, und hat versucht, möglichst wenig von diesen Ressourcen zu verschwenden. und hat dann, also das zum einen automatisiert messbar zu machen und dann sukzessive versucht, diesen Waste oder Elemente dieses Waste zu reduzieren. Also einen iterativen Ansatz, da eben mit jedem Tag eine Verbesserung reinzubekommen. Bei einer Hardwareproduktion gibt es ja jetzt noch den Vorteil, dass da auch Dinge vergleichbar sind. Energie, die ich reintue, hat einen Preis. Dann kann ich sozusagen den Waste auch in Geld ausdrücken. Das Material, was ich da reintue und waste, das musste ich vorher auch kaufen. Das hat auch einen Preis. In der Softwareproduktion ist nämlich die riesige Herausforderung, es gibt ganz viele Ideen, Ansätze, Dora zum Beispiel, oder auch weitere, die funktionieren eben nur in dem Kontext eines einzelnen Teams. Und es wäre sogar fatal, wenn man jetzt anfangen würde, diese Messpunkte, diese Metriken, also quasi die Teams in Konkurrenz oder in Gamification positiv oder überhaupt in Vergleich zu setzen. Da würde man nichts gewinnen. Weil es auch, zum einen wäre es unfair, bei Dora zum Beispiel geht es darum, wie schnell deploy ich einen Service, aber vielleicht habe ich gar keinen Service, vielleicht habe ich ein SAP-Backend, was ich einmal im halben Jahr bewusst ein neues Release drauf machen will und nicht eine App, die jede Viertelstunde quasi neu deployed werden soll. Das heißt, es ist sehr kontextabhängig, wie ich diese Metriken nehme, damit sind die nicht vergleichbar. Und den Ansatz, den wir gemacht haben, um jetzt diese Vergleichbarkeit hinzubekommen, und auch dieses Verständnis von der Hardwareproduktion auf die Softwareproduktion zu betrachten, ist zu gucken, in dem gesamten Softwareentwicklungsprozess, wo sind denn da die teuren Aspekte? Was ist die knappe Ressource? Und klar, V-Modell hat man auch, Requirements Management, fließt auch viel Gehalt rein, bei Test fließt auch Gehalt rein. Aber ich mache jetzt mal sozusagen das Feld breiter als die Embedded-Systeme, die im V eingeschränkt sind. Was man immer hat, egal was für Software, ist halt viel, viel Geld in Entwicklergehälter. Und das ist auch, man kauft sich da Experten ein und jetzt kriegen die auch noch sozusagen super Werkzeuge an die Hand, werden noch besser, noch schneller, aber trotzdem fließt das Geld da rein. Und das ist tatsächlich erstmalig, also wir beobachten es ja sehr genau, auch mit dem Hasso Plattner Institut zusammen, was passiert eigentlich an den Universitäten, kommen neue Ideen auf und da scheinen wir wirklich was entwickelt zu haben, wo man wirklich diese Vergleichbarkeit über riesige Produktionshallen schaffen kann, indem man diese Effizienz, also wie wird die kostbare Ressource Entwicklerzeit genutzt? Für wertgenerierende Dinge oder bleibt es verloren? Und das Schöne dabei ist jetzt, das ist kein Big Brother-System, was man von oben drauf stülpt, sondern das ist eine 1:1 Übersetzung von frustrierenden Dingern von Entwicklern. Das will keiner. Kein Team will die ganze Zeit, kein Entwickler will nur immer wieder Bugs fixen müssen. Und damit hat man einen Hebelpunkt, wo man eigentlich alle glücklich machen kann und dann sogar in einer Währung, die vergleichbar ist, egal ob ich jetzt gerade in einem SAP-System ABAP-Code schreibe oder ANABAP-Code schreibe oder ob ich einen C-Code für eine Bremse schreibe oder ein Java-Backend in der Bank. Und das ist sozusagen das, wo ich jetzt tatsächlich so einen Meilenstein sehe, wo man zumindest jetzt mal eine Sache hat, die man greifen, kommunizieren und wo man auch sofort eine höhere Wertschöpfung erreichen kann.
Das ist eigentlich die Zeit und das Geld, was reingesteckt wird. Die
Genau.
Ressource ist Entwicklerzeit eigentlich, wenn ich das richtig interpretiert habe. Ich möchte mal was Egoistisches machen. Ich habe super viel über Agile gelernt vor einer Weile und jetzt will überhaupt keiner mehr über Agile sprechen. Alle Gespräche, da ist nur noch von KI die Rede. Darf ich mal kurz fragen, ich will jetzt rausfinden, ob das einfach abgehakt ist, weil es ist erledigt, oder ob noch nicht. Ich möchte mal hier reinfragen, um Handzeichen bitten, wessen Organisation ist konsequent agil, so im klassischen Sinne? Oh, 2, ja, Sven, ich hätte gedacht, das hätte ich weiter gesagt. Also es gibt schon einige, es ist, das höre ich auch immer, es ist etwas in den Hintergrund geraten, aber noch lange nicht gelöst. Das ist eine kulturelle Sache. Ich möchte mal fragen, ist das jetzt vielleicht obsolet durch KI? Glaubt ihr oder glauben Sie hier, dass das nur so ein Zwischenstopp war? Das ist jetzt das modernere, schnelle Ding. Oder ist das nicht gelöst? Oder bitte um Hilfe. Wie stehen wir da?
Nee, also echte Agilität ist wichtiger denn je mit AI, weil nur so kriegen wir die schnellen Feedback-Zyklen und können schnell failen. Ja? Also Vibe-Coding ist ja sozusagen Agilität auf Drogen. Ja?
Oliver ist da.
Oh, ja, gerne.
Meine erste Gegenfrage wäre gewesen, was heißt denn konsequent? Also ich glaube, das eine ist, das agile Mindset ist ja ein Prozess, ist etwas, was nicht aufhört und deswegen ist das immer etwas, was bei uns eine Rolle spielt. Auch hinzu kommt, dass die Welt ja nicht schwarz-weiß ist, nicht 0 oder 1. Ich würde auch sagen, dass es eigentlich eine der wichtigsten Voraussetzungen ist, um mit der Geschwindigkeit und Komplexität, die nicht neu ist mit AI, aber die vielleicht nochmal zunehmend und beschleunigt wird, halt Schritt halten zu können. Also von daher würde ich sagen, ja.
Es ist noch aktuell, aber im Hype-Zyklus irgendwie verschwunden, etwas unterspült worden.
Ich referenziere jetzt einfach mal wieder meine Präsentation von heute Morgen. Wir haben auch das Agility-Monster generiert und ich bin auch bei dir, Karin. It depends. In dem Augenblick, wenn ich Brot- und Buttergeschäft mache und ich weiß ganz genau, das sind meine Abläufe und muss jetzt 1000 Motorsteuerungen im Jahr abliefern, dann mache ich nicht agil. Da gucke ich, dass ich dort höchst effizient mein Thema durchturne. Agil mache ich dann, wenn ich eben in einem volatilen Umfeld mich dahin iterieren muss, wo eben der Markt gerade den Demand sieht. Und dort bin ich auf jeden Fall mit agilen Teams zwingend unterwegs. Und bei allen anderen Themen, sage ich mal, die sehr gut etabliert sind, dann kann ich typische Kanban-Geschichten machen oder auch klassische V-Entwicklungen.
Vielen Dank. Wollt ihr euch dazu
Ja, wir haben ja auch einen Vortrag von Bayer. Dynamic Shared Ownership ist ja sehr, sehr nah an agil. Ich wüsste sogar gar nicht so den richtigen Unterschied zu beschreiben. Und das heißt ja, dass es immer noch ein sehr relevantes Thema ist, aus verkrusteten Prozessen eben es zu schaffen, dass man ja, sich hin iterieren kann zu da, wo der Markt ist, wenn man das vorher nicht weiß. Also gerne Korrektur, wenn ich das jetzt falsch eingeordnet habe. Ja.
Ich möchte dann vielleicht so zum Abschluss, danach können wir uns einfach sehr informell da beim Getränk weiter austauschen, mal fragen, das ist ja eine Sache von Kultur, die passiert. Dynamic Shared Ownership, ich weiche bewusst, welche Häresie, die Hierarchien auf in einem Konzern, der ja nur, so habe ich doch Jahrzehnte gelernt, aus Hierarchien besteht und ich muss jetzt eine höher kommen, darum geht's. Und jetzt ist die Kultur, die sich verändert und wir haben gelernt, Agile ist eine Reaktion darauf, in der Softwareentwicklung geht es nicht mit so einer Kultur. Es ist einfach unmöglich, ne, mit einem Plan vorher oder mit einer Kultur, wie, die im Wesentlichen auf Hierarchien beruht. Wie weit sind wir da oder wie ist der Status? Was würdet ihr sagen? Seht ihr da eine total tolle Rampe, die jetzt in den Erfolg mündet oder sind wir noch ganz am Anfang oder ist es das Hauptproblem mit der Kultur? Wie halten Sie es denn mit der Kultur?
Sie ist auf jeden Fall der Startpunkt für immer und ich bin auch da, also deshalb nichts dazugefügt. Ich glaube, zu Agilität kann ich nur zustimmen, den Punkten, die gemacht wurden. Wenn ich jetzt Microsoft angucke, ich muss sagen, ich bin immer wieder beeindruckt, wie sehr eine Person an der Spitze, hätte ich nicht gedacht, eine Kultur eines, keine Ahnung, 100.000 Mann-Konzerns wandeln kann. Das ist bei uns passiert und da sieht man auch, es fängt immer mit der Kultur an, ja, und das tut es auch, ich meine, die Technologie enabled, empowered und muss auch durch eine Kultur gemanagt werden. Wo sind wir da? It depends, glaube ich. Muss man fürs eigene Unternehmen, muss man im eigenen Team sagen. Ich glaube, Microsoft, klar, wir haben die Technologie, wir haben, glaube ich, jemanden an der Spitze, der die Kultur sehr ausgeprägt mit den richtigen Growth Mindset und solchen Werten lebt, die man eben dafür braucht. Ist es eine Reise? Ja, wird es immer bleiben. Also definitiv für uns auch. Also haben wir gerne auch mal wieder eine Reorg, da muss man sich neu finden, dann braucht man diese Basiskultur, muss aber die für sein eigenes Team neu etablieren. Deshalb, ich glaube, es bleibt
Peter immer eine Reise. Drucker, der Klassiker, Culture is Strategy for Breakfast.
Ja.
Oder?
Ich habe die ganze Zeit überlegt, ich bin so ein bisschen bei Bosch. Ich glaube, in großen Firmen gibt es wahrscheinlich gar nicht die eine Kultur. Also wenn ich da bei uns auf die NBW gucke, dann sehe ich die Erzeugungsanlagen, da bin ich auch froh, dass die nicht hypothesenbasiert arbeiten, sondern dass die wirklich so arbeiten, wie man ein Kraftwerk bestückt und wie man das fährt und wie man das macht, damit das Licht nicht flackert. In einem vertrieblichen Kontext ist es halt viel volatiler von den Anforderungen, da muss man halt Speed haben. Deshalb unterscheiden sich unsere Kulturen auch, wobei wir natürlich oben drüber irgendwie eine gemeinsame NBW-Identifikation haben, wo es Elemente gibt, ähnlich wie bei Microsoft, wo sich dann eine große Anzahl von Menschen identifiziert. Aber die Art und Weise, wie dann die Leistung erbracht wird, die Art und Weise, wie dann gearbeitet wird, ist wahrscheinlich in großen Konzernen und so bei Bosch auch irgendwie in dem einen größeren Bereich dann doch ein wenig anders wie in dem anderen größeren Bereich. Und das ist auch völlig okay so, weil man würde, glaube ich, einiges kaputt machen, wenn man versucht, Bereiche, die sehr unterschiedlich arbeiten, ich nehme jetzt wieder Vertrieb und Erzeugung, mit einer gleichen Kultur irgendwie anzugleichen. Das würde nicht funktionieren, weil die Menschen dahinter auch unterschiedliche Menschen sind mit unterschiedlichen Einstellungen, Leidenschaften, Passion und allem, was dazugehört.
Hans, du hast Einblick in sehr viele Konzerne.
Ja, also
unterscheiden die sich, Anwesende natürlich ausgenommen?
Ja, also ein Trend, den gibt es und gab es zu beobachten, ist, als es losging mit Agilität, dann war das erst einmal so ein komplettes auf den Rücken drehen oder auf die Beine, je nachdem, wie man es will, also auf jeden Fall anders machen, und zwar diese Selbstverantwortung in die Teams reingeben und quasi kleine Innovationskapseln zu schaffen, die selbstständig Verantwortung tragen, ne? Sozusagen also selbst Entscheidungen treffen können, aber dafür Verantwortung tragen müssen für das, was sie tun. Und als das losging, haben wir tatsächlich häufig festgestellt, dass erst hieß es so, ja, nein, also so Messapparatur, übrigens in der Agilität ist Transparenz und Messen ist das A und O. Nichtsdestotrotz hieß es immer, nein, nicht messen, das zarte Pflänzchen der Agilität wird dann wieder eingehen, und erstmal müssen wir dieses agile Mindset in die Organisation bekommen. Und das heißt, das war so die Variante, die Schwarmintelligenz wird es irgendwie richten. Wir können das eigentlich gar nicht beobachten, aber scheint ein gutes Konzept zu sein. Und dieses Agilitätspendel ist jetzt eigentlich, nachdem es einmal ins Extreme geschwungen ist, schwingt jetzt fast bei allen, kriegen wir das mit, wieder zurück, dass es so trotzdem noch eine Art Governance-Struktur oben drüber geben muss. Und das ist so was ich, wenn ich Agilität höre, immer mitschwingt. Also diese reine Agilität von damals in den Anfangszeiten, das macht keiner mehr, das wäre auch vielleicht fahrlässig sogar.
Da gibt es direkt eine Reaktion. Moment.
Ja, finde ich einen super Punkt, möchte ich gerne noch was zu sagen. Und zwar, also ich glaube auch Culture eats Strategy for Breakfast, aber auch Culture ist ja kein Selbstzweck, und sonst dient eigentlich immer dem Unternehmensziel. Und mein Gefühl ist auch, ich bin mal so als Leiter Transformation bei Funke gestartet, war, dass viele Unternehmen, da gibt es was Neues, das müssen wir jetzt machen. Das ist übrigens bei AI und Cloud-Technologie auch ähnlich gewesen, und dann wird so eine Sau durchs Dorf getrieben und dann macht man jetzt agil, und dann macht man agil, indem man halt agile Methodik nutzt, agile Methodik, und dann wird das zum Selbstzweck, und das finde ich extrem gefährlich, sondern die echte Agilität ist ja das agile Mindset, was heißt, ich nehme das richtige Werkzeug für den richtigen Zweck, und das ist durchaus eine Reise, wo man probiert und lernt kann man nur, wenn man misst. Ne? Und ich glaube, das ist einfach nochmal die Frage, vielleicht, ob das was du meinst, dass man eigentlich sagen muss, warum machen wir das Ganze eigentlich? Welchem Ziel und Zweck dient das Ganze, um da auch offen zu sein? Und das war so mein Bild und meine Erfahrung, dass oft so, wenn man anfängt, jetzt machen wir agil, okay, wir nutzen agile Methodik, aber eigentlich aus dem falschen Verständnis heraus, oft aus dem falschen Motiv vielleicht auch.
Wobei vielleicht ergänzend, ich finde die Metapher mit dem Pendel ganz gut, weil ich tatsächlich auch das Gefühl habe, viele Firmen haben angefangen mit Agilität, haben da massive Probleme gehabt in skalierter Agilität. Wenn auf einmal 60, 80, 100 Teams in irgendeiner Art und Weise skalieren, dann fängt man dann mit Safe, dann fängt man dann mit anderen Metaphern und da haben viele Firmen Schwierigkeiten. Und um diese Schwierigkeiten irgendwie wieder zu glätten, hat man wieder verstärkte Governance-Funktionen eingeführt, weil man glaubt, dass das dann besser funktioniert. Meine Wahrnehmung ist, dass tatsächlich viele Firmen mit dieser Skalierung, wenn sie neben diesen Piloten, ich mache mal eine App, ich mache mal eine Webseite, dann wirklich in den Rollout gehen und skalieren, dass sie dann irgendwann strugglen und in die Herausforderungen kommen und dann die ganz normalen Metaphern wieder gehen, dann gehe ich zu den alten Mustern zurück, die haben früher funktioniert und in der Phase befinden wir uns, glaube ich.
Okay. Aber es ist nicht am Ende, ich meine, was ja auch gerade gesagt wurde, am Ende ist es das Warum, ja, warum mache ich das überhaupt, wenn ich jetzt agil sein will, um des Selbstzwecks willen, ja, dann macht es wahrscheinlich keinen Sinn, weil ja, ich will auch nicht, dass mein Licht nicht mehr geht, ja, weil die jetzt gerade agil sind. Das Gleiche haben wir auch erlebt mit AI. Vor 2 Jahren hatten wir ganz viel die Diskussion, dass Unternehmen zu uns kamen, hey Microsoft, wir wollen was mit AI machen. Und ich dachte mir immer, was sind deine Geschäftsprobleme? Und dann können wir mal überlegen, ob man das lösen kann, nicht mit AI. Und ich glaube, da sind wir jetzt. Aber am Anfang wollte halt jeder was mit AI machen, so wie jeder Agile. Und am Ende muss ich halt zurückgehen und wahrscheinlich sagen, hey, was ist mein Unternehmenszweck? Was ist mein Warum? Und warum tue ich das gerade? Und dann finde ich hoffentlich den richtigen Weg.
Hier gibt es so einige Hype-Themen wie Blockchain, ja, also wo alle... Genau, also musste man einfach machen.
Musste man halt machen.
Ja. Und übrigens ich glaube, dieses agile Prinzip, also ich hatte vorhin ja gesagt, dass vor 5 Jahren, 6 Jahren ein Top-Entscheider hierhin kam in so Start-up-Hubs, um Innovation zu lernen. Und ich glaube, da ist so ein gewisser Kurzschluss passiert, dass man gesagt hat, naja, ein Startup ist ja innovativ, weil es agil ist. So, hat aber übersehen, dass das natürlich ein kleines Unternehmen ist und die Skalierung dann hinzukriegen, funktioniert natürlich nicht, wenn ich das nicht irgendwie in eine größere Struktur einbette. Ja,
ich suche irgendwie ein Schlusswort. Fällt jemand mal ein Schlusswort ein? Irgendwie ein bisschen ist es immer so, dass wie damals der selige Marcel Reich-Ranitzky sagt, der Vorhang fällt, wir stehen betroffen, der Vorhang fällt und alle Fragen offen. Ich bedanke mich dafür, dass Sie da waren und mit uns diese Fragen in den Raum gestellt haben. Ich bin total beeindruckt gewesen von dem Programm hier. Ich fand das wirklich großartig. Ich muss das alles noch verarbeiten. Ich finde großartig, dass Sie als Experten da waren und ich hoffe, wir haben jetzt noch ein Getränk und ein gutes Gespräch. Vielen Dank, dass Sie da waren und beehren Sie uns bald wieder im Software Excellence Network. Vielen Dank.
Vielen Dank, es war mir eine Ehre.